afternoon, good evening to everyone. I would like to welcome you on behalf of the United Nations Office for Outer Space Affairs, who is the host of this 7th IAA Planetary Defense Conference in cooperation with the European Space Agency, to the day 4 of this conference, today Thursday. The focus of today is impact effects and disaster management. We have also an exciting public event later on today from 5 to 6 p.m. Vienna time or 3 to 4 p.m. UTC. The public event is hosted by the Planetary Society. It's a live public event. We will post the information in the chat, the link that you can join. The title is also very enticing. It's called Earthlings versus Asteroids. So it should be a very lively discussion that you can also follow on other social media channels. Also from our side, as the host, I'd like to inform you that we have quite a really good global reach of this conference. So far, with in total for the 3 days, we had 650 unique users. We also have available recordings of the day 1. I will post the link in the chat. So for those of you, due to different time zones, who were not able to follow the whole conference, the recordings will also be online. Without further ado, I don't think I have forgotten anything. So the chat function is available for you to post questions and communicate with everyone. And I see another good morning from Brazil. Good morning to Brazil. Thank you for all to join us so early as well. We really appreciate. We have tried to structure the conference in a way that is available to most of the time zones. So thank you very much and welcome. Over to you, Alex.
Thank you very much, Romana. And on behalf of the PDC co-chairs, I would like to welcome you as well for day 4. Today, the sessions will focus on impact effects and disaster management. And as Romana already mentioned, there is, during our Green Zone today, we have 2 panels. First one is about reliable communication and dealing with misinformation, and the other one is about lessons learned from past disasters, recommendations for real neo threat, and the one that Romana already pointed to, the public event from the Planetary Society. So it's promising to be another very interesting day with interesting discussions. A bit to the logistical side. As yesterday, we found that posting the questions in the chat seems to be working better for everyone. So you will notice there's no Q&A section anymore. So please use the chat to post questions and make sure you address them to everyone so everyone can see them and then respond, hopefully. During the breaks in general, you are welcome to join the breakout rooms for a bit of socializing, and I've seen the link already posted in the chat. So that is open during all the breaks today and also after the end of the conference day. So feel free to mingle, have your coffee, get to know some new people, maybe some old people. And during the breaks in the Green Zone, in addition, we will have the usual polls open. So take advantage of that as well. And I believe that is all I have. We are still a few minutes early. So I'm not sure, Romana, Gerhard, shall we start early or shall we wait? What's your preference there?
We should wait. We start 12 sharp. So
yeah, I think we wait.
Everyone is invited to grab coffee. Or I see good morning from Tokyo, which means that they are probably it's dinner time. Not probably. for sure. Yeah, let's wait a little bit until 12 and we start at 12.
Okay, so we have another 5 minutes before I'll hand it over to the session chair of session 9A. And maybe in the meantime, if there are any questions already for logistical things, you can post them in the chat.
Yeah, in the chat we have some notifications. First of all, from Jan Timo Grundman to everyone. Remember to post to everyone, not to all attendees. So that's the last option at the very end of the list. So not to get confusing. Then Peter Kran, of my colleague from the European Space Agency's Conference Bureau, posted already a link with the program. There you have all presentations, e-lightning talks, also the link to the recordings and the link to the public event, which will be later today. So that's a very useful one-stop shop to go to. And I see we have good morning from Georgia, USA. Great.
Yeah, and picking up on the link from Peter, I really encourage everyone to have a look at the e-lightning talks and e-posters. You have been watching the sessions here in live presentation, but we had a record number of abstracts we accepted this year. So you find a lot of good quality work also in the e-lightning talks and posters. So please have a look.
Yeah, and this morning, the presenter who will run the slides is Daniel Grossrank from the Austrian Space Forum, and I'd like to thank him because he and Jenny have been very helpful in running this conference so smoothly. So Daniel, thank you, because I saw also Rudy Albrecht joined. He kindly proposed Daniel, and I'd like to really thank our team for making this conference run so smoothly. So we have 100 participants. Let me see. What about the attendees? 79. Good. So we'll wait a couple of more minutes and then we start at 12. And I wish you a good day.
And I see a question there from Dan Mazanek that so far it appears that only the recordings of day one are available. And that is correct, Dan. I believe Romana's team is still working on the following days, but as soon as they are ready, they will be posted and shared as well.
Yes, exactly, Dan. Those are huge files that are being, transformed every evening after the conference. Conference finishes quite late at 8 p.m. Vienna time. So before they are sort of structured and looked over, it takes some time. So thank you for your patience, but we will inform you when they're all available. Thanks, Dan, for understanding.
Maybe one note, I just realized how quickly the week is going and it's already day 4. And if I'm not mistaken, that would usually be the day of the gala dinner. So just to point out what we're all missing today. But hopefully in 2 years, we can all meet in person in Vienna and then have social events again, like the gala dinner. Maybe you can all bring food to the breakout rooms after today's sessions are over and have a little virtual dinner there. That would be nice.
I also see a question, how long will the recordings be available for viewing? They will be archived, so they will remain available. So as you know, the holder of this conference is IAA, International Academy of Astronautics, and they have created the repository, so they keep the conference website, and all information is linked then to their website, so they will remain available. Yeah. Good, Alex. So over to you. I think you can introduce the first session chair,
Yeah,
and
we have
we start.
1 minute left. So it's my pleasure to hand over to Dr. Olga Popova, who will be chairing session 9A on impact effects. Olga.
Yeah, good morning to everyone. Just now we will start our morning session of the part 9A, impact effects. And the first presentation is titled Studying Bodies of Organisms Killed by an Asteroid, Environmental Effects of Very Small Crater Formation. And I'd like to remind that the length of the talk will be 8 minutes, and we will have questions after all talks will be finished. So I'd like to ask Anna to start our session.
I'm ready. Can I have my slides, please?
Slides, please show slides.
Okay, hi. So I'm going to tell you what would happen if the asteroid that is going to hit us is on the smallest side of the prescribed scenarios, so a couple tens of meters tops. Next slide, please. As we all know, the large impact craters can have very global effects with the killing of dinosaurs and making this meeting possible, but by removing those evil T-Rexes so that we can now evolve into talking about them instead of dying. Next slide, please. Yes. But what about the very small impact craters? Currently, we know about only 200 places on Earth where such a cosmic catastrophe took place, and they are marked with different colors indicating their ages on this map. However, we know about 17 craters that are less than 200 meters in diameter that are of interest to me, that are marked with those black stars here. Next slide, please. So we know, even though those 17 known impact craters less than 200 meters consist of quite large portion of those 200 craters that we know of, they are still very highly undercounted. That is indicated by this orange triangle visible on the plot. The plot is showing the current impact rate as we understand it now to Earth. The left top part is showing the smallest particles that are impacting all the time, and with moving to the right, we are going to the crater forming impactors. And as we can see, there's this discrepancy between the known craters of different sizes of the smaller sizes and the expected impact rate. During the Holocene alone, there should be about 20 impact craters, but we know only about 5. And this discrepancy can be caused by either not being able to detect and prove that some holes in the ground are made by impact craters, or by the fact that our estimations of the impact rate are not very good for this particular size range, or that we do not understand very well how the energy is partitioned between the atmosphere and the surface of Earth during those very small impact craters. And most probably all of those three answers are to some degree important, and this is what my talk is all about. Next slide, please. The studies of environmental effects have been of those very small impact craters. There are only a couple of them. Most of people focus on those large ones, but one of them, the most canonical one for a very long time, was one of Kali crater. Kali is a strong field. The largest crater, not the largest impactor. The largest crater is 100 meters in diameter, and it's in Estonia. It was studied, environmental effects of this impact was studied by Vesky by drilling into the Pila bog that is about 8 kilometers from the impact site and trying to detect any environmental changes that could have been induced by the at the time of the impact. Unfortunately, he selected the depth of the drill core incorrectly, as it was revealed many years afterwards. So the changes that he found and at first assigned to the effects of impact of Kali crater are most probably due to human impact. Next slide, please. So no effects detected at Kali. Similar study was repeated at the Morasco site. Morasco, again, thrown field, the largest crater, 100 meters in diameter, and it was studied, environmental effects were studied based on drill cores in the lake, about 5 kilometers from the impact site. Next slide, please. And this time it was well targeted, but there are absolutely no effects that are detectable at this time. So, and a lot of different proxies were studied. I only show a couple of them here. So absolutely nothing that is detectable. It doesn't mean that there wasn't any effects, environmental effects. It means that they are not detectable 5 kilometers from the impact sites and 5,000 years afterwards. Next slide, please. However, there are some strange effects that we have relatively recently found in the proximal ejecta blanket that show that we do not understand the process of the energy distribution around those small impact craters. And there are some environmental effects that we really do not expect, and they are not reproduced in the currently used numerical models. Those are finding impact charcoals within the proximal ejecta blanket that have been formed by the impact itself. Next slide, please. Those charcoals have been found in many different locations, not only in Ulumetsa, Kali, Morasco in Europe, but also in Whitecourt in Canada, and some literature reviews show that they were also present in other locations, however, not recognized as anything worth studying further. Next slide, please. All of those charcoals are present within the kind of ring around the crater. Different craters have similar distribution scales for the size. So the 100 meters in diameter Kali and the much smaller 30 meters in diameter Kali 8 also have those things. Most of those charcoals are very close to the ejecta base, and the double charcoal layer is present at the overlapping craters. Next slide, please. All of those charcoals have been formed at exactly the same time within the, of course, C14 dating, and so different charcoals from different craters within the thrown field are of the same age and also of the same age as independently determined age of the crater. So they were all killed at the same moment. Next slide, please. And what we really studied was the reflectance of those charcoals. Reflectance is something that is telling us about the amount of energy that is devoted, that is required to form a piece of charcoal. In short, less reflective charcoals visible on the left require much less energy to form than the ones that are more reflective visible on the right. Very simple. Energy meaning the amount of like, let's say, temperature over time, if we kind of simplify that. In the middle, you can see the histogram of measurements of one of the impact sites, impact charcoal sites, and the representative wildfire charcoal. You can see that those reflectances are very different, recognizably different, and also that the charcoal from wildfires is much more energetic than the impact charcoal, and also much more diverse. The impact charcoals from all locations are very...
Sorry, 1 minute left.
Sure. Are very similar to each other, even though they are formed on different continents and over many different time moments. thousands of years difference, and all exactly the same, which suggests us that the whatever process forms those charcoals is reproducible in many different locations. And the last slide, please. And we have performed a lot of experiments, laboratory experiments, in order to try to reproduce the process and produce artificially charcoals that are the most similar in properties, all properties, to the charcoals found in the proximal ejecta blanket. And the most similar way to produce those is by burying the wood, fresh wood, for example, spruce wood that we found in the real life, in the heated sand. The heated sand should be heated to about 550 degrees, and then we reproduce something like we can see in the proximal ejecta blankets. All other ways, including producing like kind of forest fires or short, very intensive pulses of heat, do not produce charcoals of similar properties. Last slide, please. And if you have any questions about those strange things or working in the field at the impact site, I will be very happy to help. And I will be also very happy to, very grateful for any suggestions on how to explain formation of those evil charcoals that are very enigmatic. Thank you.
Thank you very much, Anya, for this fascinating talk, and it's very interesting for us. And I hope that any ideas will appear, maybe even during our session. Okay, thank you. We will move to the next presentation. It will be done by Sunhai Hao from Hypervelocity Aerodynamics Institute of China, Aerodynamics Research and Development Center. And the title is the Melting Ablation Analysis of Aerolites in High Temperature Flow.
I'm sorry, this is not my PPT.
Yes, it looks some other presentation. Can you find? No.
Yeah, this one.
Yes,
Yeah.
great. That's this one. Please start.
Hello, everybody. My name is Sunhan Hao from China Aerodynamics Research and Development Center. This is our planetary defense team. It's my pleasure to share some work by our team. The next presentation is also from my colleague, Su Yao. He will use the simple count. Besides, we also have 3 posters and an e-lighting talk in the conference. The presentation title is The Melting Ablation Analysis of Meteorites in High Temperature Flow. Next, please. Next, please. Yeah, it follows those 4 parts. Next, let's go to the first part, the background. Yeah. The strike from the asteroid could cause significant devastation to the Earth that we can't afford. Next. Yeah. During the Earth's entry of asteroid, the air heat could lead to melt, evaporate, spore, fragment, and then disintegrate. All will lead to massive mass loss and change the final trajectories. The previous work by many research indicates that the ablation coefficient affects airburst height and ground damage area largely, but it has a large uncertainty. Aiming to reduce the uncertainty and reveal ablation mechanism, NASA and BKI has conducted a field of research. In this presentation, I will introduce our preliminary work. Next. Now let's go to the second part, some basic situation about our experiment. The red top finger shows the raw meteorite we used in this experiment. It belongs to the L5 ordinary chondrite. It was machined into 5 spherical cone samples with a height radius of 20 millimeters. We designed 3 different states. The experiments at the low state were conducted in the first phase, and the experimenters are listed in the table. Next. Yeah. This is a sketch of the experiment facility. The gas fitted by the actuator is accelerated by the nozzle, forming a supersonic high temperature airflow. The sample surface temperature is measured by the parameter, and the ablation shape change is recorded by the camera. Next. The left finger shows the melt flow over the meteorite sample during arctic exploration. We can clearly observe the shape change is getting more and more blunt, and the right finger is the post-test shape of the number 4 sample. Next, please. The left finger is the transient shape obtained from the video, and the right finger gives the ablation recession with the time and the stagnation. The recession rate is nearly constant, and the total amount is about 3.6 millimeters. Next, please. Okay, let's go to the third part, the melt ablation model. We compute ablation in a decoupling way. The hypersonic reacting flow is solved by CFD to get the pressure gradient, shear force, and the air heat at the wall. For the melt layer, use the melt ablation model proposed in 1956 for glassy materials and a series of assumptions. Next, please. The mass loss caused by 2 different forms, that is the evaporation and the motion of the liquid layer is given. Both of them are the function of the temperature. Next, please. The mass loss, as in the flowchart, we gradually raise the temperature until the surface energy balance is satisfied. Then we can get the final solution. Next, please. To validate the theory model, we choose the fused quartz experiment conducted by AMS Research Center as a case. Next, please. First, we employ CFD to get flow field, pressure, and friction along the surface. Next slide, please. This is the simulated ablation result. Both the temperature distribution and the computation surface profile are in good agreement with the merit date. Next slide, please. In the final part, we employ the above model to make analysis for the experiment in the second part. The whole flow field is obtained by the CFD. The right finger shows the local temperature field around the sample. The right finger shows the wall friction distribution. Next, please. Yeah, the left finger shows the comparison of the stagnation point recession between the computation, the blank solid line, and with the measurement, the red symbol. The result is satisfactory, although it's slightly lower. The right finger shows the surface temperature distribution with the maximum value of 2770 Kelvin. It's much higher than the measured results. This issue should be further analyzed. Next, please. Next, please. Yeah. Unexpectedly, for the number 1 sample with the same experimental environment, the fragmentation occurred during the exploring time. The left finger shows the final ablation shape. It's irregular. The fragmentation becomes the decisive factor of the final shape, and the melt ablation model is not applicable anymore. We infer that the thermal stress is the reason, so make a stress analysis. The right finger is the thermal stress at the 4th second, and the maximum value is about 380 megapascal, which exceeds this material's average strength. So the thermal stress is an important factor that leads to the mass loss, which should be considered in the following work. Next, please. Finally, some brief conclusion. The ablation recession rate and the final ablation shape is consistent with the experiment result. And higher viscosity leads to the lower mass loss rate by the motion of the melt layer. More energy are balanced by the evaporation. The surface temperature increases and the total mass loss rate decreases. The thermal stress caused by the temperature gradient exceeds the material strength, which is the reason of the fragmentation. Next, please. In the future, there are some work which should be done. That's all. Thank you.
Thank you very much for this fascinating talk. And I'd like to remind that all questions can be written in the chat section, and we will talk about them later after all presentations. And we move to the next talk, which will be presented by Susi Yao, and it is titled Numerical Analysis via Dynamic Heating of an Asteroid During Entry to the Earth's Atmosphere. And again, for the same group from Hypervelocity Aerodynamics Institute of China.
Okay, thank you. Am I ready? Okay. Hello, everyone. I'm very glad to have this chance to present our work on aerodynamic heating analysis of an asteroid. Next, please. This talk contains 4 parts. Firstly, I will give a brief introduction of the background. Next, please. Next. Okay. Depending on the size and velocity, the consequences of the asteroid entry could be numerous. Next, please. Okay. There is some entry event in China. Next, please. In this talk, we will focus on the aerodynamic heating as it's an important factor in determining the mass loss rate. Okay, next, please. Now we will introduce the numeric method and the physical-chemical models. Okay. There are obvious differences between vehicle re-entry and asteroid entry. And so could the numeric method and the models proposed for re-entry vehicles used for asteroid entry should be checked. Next. As the primary origin of asteroid entry is continuous or near continuous, so the safety method might be applicable. However, the physical-chemical models relevant to high temperature gas effect of traditional CFD should be confirmed and improved. Next, please. First of all, the thermodynamic properties of the ultra-high temperature gas should be confirmed. Next, please. Then, high accuracy database of collision cross-section are also needed. Next, please. Then, new chemical kinetics, such as multiple stage ionization, photochemical kinetics, and chemical kinetics for ablation products should be developed. Next, please. Then, the internal degree relation models parameters, such as vibrational reaction time, need to be validated at ultra-high temperature. Next, please. Finally, the radiation mode of asteroid ablation products should also be developed. Next, please. In this study, the numeric tool uses the Athens code developed at our institute. And here is the numeric method. Next, please. The high temperature gas mode. Next, please. And this is the boundary conditions can be used. Next, please. We use a non-Boltzmann board for the radiation computation. The line information and the cross-section following the work of Johnston. Next, please. We use the tangent slab approximation to compute the rate transfer equations. Next, please. Next. And finally, we use a loosely coupled approach to couple the simulation of the flow and the radiation. Next, please. Here, then we will introduce the results. Firstly, we can see there is for reventure vehicle. The radiation flow coupling effect is relatively small, and the flow field of the revenue vehicle. Next, please. The convective is the dominated mechanism of the aerodynamic heating. For revenue vehicle, uncoupled radiation simulation can be adopted. Next, please. Then, coupled and uncoupled radiation simulation are carried out for typical asteroid entry conditions to investigate the influence of radiation flow coupling. Next, please. We can see the radiation flow coupling effect plays a significant role in the flow structure of asteroid entry. Compared with the uncoupled case, the temperature and the thickness of the shock layer are much smaller. Next, please. With the increase of entry velocity, the coupling effect on the flow field is enhanced, and the variations of the shock standoff distance and peak temperature are enough. Next, please. The radiative cooling and the thin shock layer are the physical mechanism that radiation flow coupling will ease the area heating. Next, please. Okay. There are obvious difference of heating character between asteroid entry and hypersonic vehicle re-entry. First, the radiative heating is dominant for asteroid entry, and the convective heating is negligible. Total heat flux at stabilization point increases with the diameter. Next, please. Now we introduce the summary. First, hypervelocity aerodynamics plays an important role in the analysis of asteroid impacting the Earth. Next, please. In order to investigate the aerodynamics performed in asteroid entry to Earth, the high temperature gas models, such as the thermochemical model and the radiation data, need to be extended to greater than 20,000 Kelvin. Since there are strong coupling effects among the flow field, radiation, and ablation in Earth's entry problem, both the coupling mechanism and the numeric method are needed to be further explored. Okay. That's all. Thanks for your attention.
Thank you very much for your very informative presentation, and we will move forward to next talk. And the next talk will be presented by Dmitry Glazachev from Institute of Geosphere Dynamics, and its title is Impact Effects Calculator, Shockwave Effect from Impacts of Cosmic Objects with Diameter from a few meters to 3 kilometers.
Hello, everyone. I will talk about the impact effect calculator based on the result of our group from the Institute of Geosphere Dynamics. Next slide, please. It is not possible to make a full-scale laboratory experiment of hazardous impacts. So there is only a way to get some result. It is numerical modeling, but it needs a huge amount of time and resources. Scaling correlations provide a quick tool to estimate consequences of impact for a wide range of impact parameters. And we create easy-to-use online calculator which use these scaling correlations. Next, please. A numerical model based on the Sava code is used to describe the impact of the cosmic object. The modeling is carried out in two stages. At the first stage of simulation, the hydrodynamic and thermodynamic variables are obtained in the frame of a two-dimensional quasi-liquid model. And in the second stage, the shock wave propagation is modeled in 3 dimensions. As an example, the picture demonstrates the destruction of a 40 meters asteroid in the atmosphere. Next, please. This is result of modeling. The picture demonstrates the maximal overpressure distribution for one of the impact variant. You can see asymmetric shape of the distribution. It is not clear for oblique impacts. Next slide, please. Here you can see the summary of modeled variants. We considered 81 different cases, which includes asteroids and comets with different sizes, entry angles, and velocities. The effective altitude for every variant is shown in dependence on kinetic energy. This altitude is not zero for airburst and on the left side, and equals 0 for crater forming impacts on the right. Next slide, please. The effective altitude is determined by the altitude of energy release maximum. It depends on the density, size, and entry angle of the impactor. The effective altitude has the precision of about a few kilometers. Next, please. The effective altitude permits us to divide all possible cases on airburst, crater forming, and transitional variants. In transitional area, some intermediate between airburst and crater forming scenario will be realized. Next slide, please. We found a good scaling correlation that interpolates between results of numerical simulations. The scaling correlations depends on kinetic energy and some power, distance from the epicenter, and effective altitude. It also includes spatial heterogeneity with the ellipticity parameter. Next, please. Left panel demonstrates the comparison of scaling overpressure solid lines and modeled dashed lines. The right panel shows the relative error. Green area is very good. Blue and yellow slightly worse, but also good. Next, please. We compared our scalings with the Collins model. Our Collins model is based on explosions results and does not include spatial heterogeneity induced by impact angle. For this particular variant, we are slightly better. Next, please. And next one, please. Yes. These overpressure fields demonstrate how the damaged area is growing with the impactor diameter. For 50 meters impactor, a glass will be damaged at a distance of about from 75 to 100 kilometers from the epicenter. And for 150 meters impactor, this distance will be from 100 to 200 kilometers, in dependence on the directions. The directions in such cases is significant. Next, please. the overpressure distributions is shown for a bigger asteroid. And next, please. And just for demonstration, the variation of the entry angle causes the changes in overpressure distributions. Once again, the direction is significant. Next, please. We have applied our scaling relation for Tunguska and Chelyabinsk event. The resulting overpressure is agreement with observed glass damage in both cases, and the following trees for Tunguska. Next, please. Our scaling relations are implemented into a web calculator. You see the main page here. We set the impact parameters and observation point of the effect. And when we press the Run Calculation button, we go to result page. Next slide, please. This is result page. Every block represents the specific damage effect. And next, please. Every block can be expanded to see the details of the effect. We estimated also effective altitude, maximal overpressure, areas where overpressure exceeds some specific levels, and maximal wind speed behind the shock front. Next, please. Our site also provides possibility to use API, Application Program Interface. You see example for from Mathematica. So you can do a series of queries and retrieve the dependency you need. Next one, please. And this is our summary. And it's all. Thank you for attention.
Thank you very much for nice talk. And now we will move to the last talk of our morning impact effects section. And this talk I will present myself. And the title of my talk is Radiation and Some Other Effects Included into the Impact Effects Calculator. Next slide, please. Asteroid and comet impacts for a wide range of diameters, entry angles, and velocities were numerically modeled in the frame of impact SAVA model. More than 100 cases were considered. The impact scenario is determined by impactor size, density, and entry angle, and boundary between airburst cases and crater formings is not very certain. The intermediate scenarios where the comparable amount of energy, internal kinetic energy, is released in the atmosphere and in the ground are possible. And the transition scenario for asteroids occur approximately in the range from 60 to 250 meters, just the range of our probable PDC exercise. Next slide, please. The hydrodynamical parameters and thermodynamical parameters obtained in the frame of the impact simulations were used to determine the radiation fluxes and thermal exposure on the ground. The equation of radiative transfer was solved along rays crossing the heated volume of air and vapor, and later the intensities were integrated over all angles and over the whole spectra, provide us the thermal exposure field on the ground. Next slide, please. The main input into the radiation from the impact came from bolide radiation for airburst cases, and this radiation can be intense enough to cause fires on quite large areas. And in crater forming cases, the main input from the plume radiation causes also very dangerous thermal effects on the surface. Even some melting of the surface layer is possible for enough large impactor. Next slide, please. These serial simulations give us possibility to suggest scaling relations for thermal exposure, and you can see this relation here. In fact, it is the point source approximation which is corrected on spatial heterogeneity. We consider mainly the range from 10 to 500 joule per square centimeter for thermal exposure, because the first value corresponds roughly to the first degree burn, and the last value essentially exceeds the amount needs to ignite most material. Next slide, please. Important parameters which is included into scaling relations is the integral luminous efficiency, the fraction of impactor kinetic energy which is converted into the radiation. And here you can see how it changes with impactor energy. It increases for small meter scale impactors and has maximal value of about 20% for example, asteroid 20 meter in size, and similar to Chelyabinsk, and then it's decreasing with size and energy, probably because the optical thickness is increasing of the emitting region, and this leads to radiation losses mainly from its surface. Minimal efficiency is obtained through transitional cases between airburst to crater formings, and probably it is connected with the change of main input into radiation from bolide to rarefied plume, but this is still to be clarified further. Next slide, please. Scaling relations we found for airburst for integral luminous efficiency are written separately for asteroids and comets. For any other density, the linear interpolation works well, and for crater formings, we suggest the uniform relation for integral luminous efficiency. Next slide, please. One more parameter included in scaling is radiative altitude. For airbursts, the radiation can be represented as radiation of the source at this radiation altitude, which varies with impactor parameters from, I don't know, 30 to 40 kilometers down to the ground. And this radiative altitude is larger than effective altitude for the same impactor, and so the maximal thermal effect is shifted relatively the overpressure maximum. For crater formings, radiation altitude is just an adjustable parameter, and it is not the effective source height. Next slide, please. Here you can see the comparison of numerical simulation results, solid lines, and our scalings, dashed lines, and gray filling demonstrates the relative error. And ellipticity, which is included into scalings, allows us to reproduce the inhomogeneity of the radiation field. And our scalings provide the uncertainty of about 2 times, which we think is reasonable. Next slide, please. We also compared our numerical modeling results and scalings with existing observational data, for example, for Tunguska. Parameters for Tunguska impactor is quite uncertain, but nevertheless, the data to fit the area of burnt trees is reproducible. And we compare our scaling with independent model recently published by Johnson and Stern, also for Tunguska. You can see this over the right panel. The top panel is for Johnson and Stern, and the bottom panel is for our scaling relations. And you can see that they are in agreement. So despite we are not sure in concrete parameters of Tunguska, some of them allow us to reproduce the radiation field, and results from 2 different models are in agreement. Also, we suggest probably more oblique impact. Next slide, please. Here, just comparison of our scalings with simulations for crater forming event, and spatial heterogeneity is excluded from the scalings here, and uncertainty in most cases is of about 2-4 times and does not exceed 4 times in our interesting range of thermal exposure. Next slide, please. Here you can see some example of thermal exposure fields for PDC exercise. And for 150 meters impactor, it can be both airburst and crater forming events. It will be dependent on how the fragmentation in the case of the entry will proceed. But we may estimate for this size of the body, the scale of the area of first burn per-degree burn is of about 200 kilometers. Next slide, please. There are considerable density and temperature disturbances in the upper atmosphere, and the heated material is moving upward and expands laterally, and these disturbances spread over thousands of kilometers at altitudes higher than 100 kilometers. You can see how these disturbances are evolved with time. Next slide, please. And we include these atmospheric disturbances into our calculator. We suggest to describe them by disturbance parameters Xi, which is in fact relative density. And the maximum Xi occurs in the vicinity of the epicenter, and it decreases at the scale of 1,000 kilometers. We compare these disturbances for explosion and impact, and we see that the impact is more productive in such disturbances. Next slide, please. The only instrumental data on atmospheric disturbances are from Chelyabinsk event, and we compare our modeling with this data with the well-pronounced and total electronic content disturbances with an average period 10 minutes. And the comparison is given on the right panel, and you see that they're in agreement with observations. For PDC impact, we may predict the atmospheric disturbances as strong as 10 in the third or in fourth power. Next slide, please. One more effect included in the calculator is the seismic effect. To calculate the seismic magnitude, one needs to know seismic efficiency, and we modeled seismic efficiency both for airburst and crater forming effect impacts, and we found that it deviates from usually used in modeling or in Collins calculator. Next slide, please. And for PDC impactor, we predict the seismic magnitude of about 6. Next slide, please. And here are our concluding remarks. Thank you for your attention. So, I'm slightly late, I'm sorry. Okay, nevertheless, we have time to answer questions, and many presenters answer questions in the chat, but maybe you'd like to continue your comments to these questions. Anya, do you like to answer more on questions you write here?
Sorry, yeah, there was quite
we don't hear you.
Sorry, can you hear me right now? Hear me right now, or now?
Sorry, your microphone, Anya.
Yes.
Dear Anya, sorry to interrupt. I can hear you.
Okay. So some people can hear me, some people cannot. Okay.
I think so.
Oh,
Olga, can you hear
Anya?
I think that most people can hear me, so I will just try to answer. Okay, perfect. So there was a very interesting, a lot of very interesting questions concerning possible human sources for those charcoals, but it's not possible. For 3 reasons. First of all, the sedimentological location of those charcoals suggests that they were not disturbed. And they are quite deep within the ejecta. So the ejecta is forming kind of like a wedge, and at the end of the wedge, furthest from the rim, they are on quite low depths, but you know, at the other side, close to the rim, they can be at depths of a couple of meters at least. So, you know, someone would have to, like, it's not realistic. Second of all, the dates of some of those charcoal searches that those charcoals were formed before people arrived there or arrived at large numbers. And third of all, the reflectance properties do not agree with what we would form during the, let's say, bonfire or something. The charcoals are like if we just consider the reflectance alone are quite similar to what we can produce or people used to produce in the charcoal, artificial charcoal producing things, the clamps, but the energies reflected in the reflectance of charcoal are much lower. So human produced system is not possible. There were also some discussions about how the process can be formed and the kind of incoming jet of heating of the material, if this could be responsible for producing charcoal. I guess it can have some effect, but the largest problem is that there has to be sustained heating to produce this charcoal for at least a couple of minutes. Without that, like there will be no charcoal or there will be no, and the very small amount of charcoal that will be formed will have very different properties from what we are finding. Yeah, so that's kind of.
Thank you very much, Anya. Thank you.
But I'm really, really grateful for all the questions and discussions. And if you have, any other ideas, please let me know, because I'm really I'm out of the ideas how to explain those things. So
okay. Thank you, Anya, again. And we have question to Mr. Sun Hai Hao. Do you hear us? There is a question. Did you record the sample behavior in the wind tunnel? Do you have such video?
I'm sorry. Can you hear me? Hey, can you hear me?
Do I need to repeat?
We can hear you.
Okay. There is a question to you. You demonstrate fascinating photo of the sample in the wind tunnel. Do you record some kind of movie of these tests?
Yes, we have recorded a few videos. It's a little bit that we can't create in the PDF file. Yeah.
Mm-hmm. Great,
That's
thanks.
the
And
reason.
I also have a question to you. You modeled the ablation included two processes, evaporation and melting layer removal. What process is most important or provides a greater impact in your condition?
It's almost half to half, and dependent to the specific condition. Yeah.
Yes. So, do you expect, for example, the melting removal is more important at higher altitudes of the flight, or where?
If at a high temperature, the evaporation will become the main mass loss forms, and if the and at the low temperature, the motion of the liquid layer is the main forms. That's all.
Mm-hmm. Thank you very much. And we have question for Mr. Su Xiao. And the question is, did you calculate the temporal evolution of the spectral radiation from the fireball?
I have just calculated some typical conditions.
Mm-hmm. So you do not model the nearby wake. You are just considering the area in front of the meteoroid.
Yes, just some typical entry conditions. We haven't calculated the time dependent case.
Thank you very much. Next question. We have question to Dmitry Glazachev, and the question is, in your presentation, which theory supports the scaling relation of overpressure, and what assumptions are in it?
Yes. Our scaling relation is a little variation of the point source distribution at some altitude. We use the idea of the dependence of kinetic energy at the power of 1.3 by last one Dolan, and clarify all parameters using our measure of calculated variance. Also, we do this separately for airburst and crater forming events, and for special heterogeneity, currently we choose free direction for get some fixes for distribution. It is a forward to trajectory and after point of maximal angular release, and backward from this point to, and in the perpendicular direction, because there is some symmetry of this. That's all.
And I have a question to myself, and the question is, according to your simulation, luminous efficiency is a little larger than Collins' model, which was used in probability impact risk assessment by NASA. For example, in your literature, the luminous efficiency is about 0.25 for an asteroid of diameter 100 meters and velocity 20 kilometers per second. In Collins' model, luminous efficiency is between 10 to minus 4 to 10 to minus 1. Can you explain the difference? Collins' model is based on some early modeling efforts, and he collected all information he has at the time when he created his model. And for our scalings, we provide a set of numerical simulations based on our impact model. And so we got new information about the luminous efficiency during these impacts, and we created our scalings trying to fit the result of numerical modeling in specially elaborated impact model. Do we have more new questions here? You are welcome to put. We have a few minutes left.
So maybe there are some new questions, so I can maybe answer them instead of type them.
Yeah, sure.
Sure. Yeah, so there was an interesting question if we are sure that the charcoal is organic in origin. Yes, we are. You know, the charcoal has preserved structure of wood that is preserved in a good enough way that allows us to identify what kind of wood it is. And we are, for example, sure that in Cali it was spruce branches that were burnt and well, burnt, not necessarily burnt, charred and changed from wood to char. So we are quite sure about that. Yeah, and there is also discussion about how hot the ejecta is, and you know, according to the our understanding of modeling, numerical modeling of those charcoals, of those craters, small impact craters, they should be cold. And the problem is that if we cover the hot initially on fire pieces of branches with cold sediments, that they will just go out and the process will just stop. So they will not produce charcoal with properties that we observe. Yes, that's all.
Thank you, Anya. And I have a question to myself. Do you have an opinion on the possibility of risk to satellites in LEO orbit from ballistic plume ejection? In fact, I'm not sure, of course, but I guess that the increase of relative density and temperature in surroundings of the satellite may be dangerous, especially for radio connections with it, and maybe, I don't know, some increase of satellite deceleration may be observed also, but of course it's still not clear. And we have probably last question to Dmitry, and the question is, where is it? If we know the impact conditions from an approaching asteroid, can you communicate those values to app users so people in the region can use it to measure their local danger?
Yes, of course, if we know the exact condition of the impact, when anyone can use data to estimate the consequences in this specific location. So the observation point is the specific location for estimate the effect. But general notification for all citizens must be carried out by the specific services.
Thank you.
Good morning, everyone. Good morning, good afternoon, good evening to all of our colleagues internationally. Welcome to the Disaster Management Session 10A. We're going to have 4 presentations today. Each presenter will have approximately 10 minutes to leave plenty of time for questions from our international participants. So looking forward to following up a great disaster management expert panel we had yesterday. And our first presenter will be Mr. Chandola. Mr. Chandola, please proceed.
Thank you so much. Dear all respected panelists and all the audience. So my name is Deepak Chand Chandola and I am working in aviation faculty in Abu Dhabi Polytechnic College here in UAE, Middle East. So I am presenting today about key aspects of disaster management. My presentation is purely qualitative, research-based presentation. I have prepared a research paper and these are some of the snapshots from my research. So next, please. Next slide, please. So during this presentation, I will be covering a review of disaster management, how to establish a framework, identify key aspects related to disaster management, and then associated factors. Before proceeding further, I would like to mention that disasters, like all the disaster response and the management, having a same basic or foundational approach. So I'm going to present all the aspects in this regard. Next slide, please. Okay, so first of all, why we need the disaster management? Next slide, please. So first of all, we need to know that what are the effects which causing us to need for the disaster management. There are financial aspects, social aspects, and mental aspects. Financial because of the damage to the infrastructure, social because of loss of lives and the people, and mental because of the fear factor due to disastrous events. Next slide, please. So to make the disaster framework, what are the essential needs? First of all, we need to know during disaster management what to do and how to do whatever we have decided how to do, and what are the steps we can take or we have to prepare so that in future the same instance should not appear again. Next slide, please. So now I'm going to discuss about reasons for the disastrous events or disastrous instance which is happening so fast. Next slide, please. So based on the research papers, I have identified there are 3 main reasons which and majority goes to man-made reasons, because these are developed because of the technological advancement, or there is an imbalance between the people and nature, and there are some other associated factors. Second is natural reasons. Natural reasons like sometime earthquake or some other things happening in the world, as we have seen, as we are seeing it. So these all are some of the reasons. And the third one, which is near Earth objects. So those objects which are heading to the Earth, how they are they want us to prepare ourselves for any disastrous event which may be possibly occur. Next slide, please. Now I'm going to discuss about established disaster management framework, how we can establish an effective framework for disaster management. Next slide, please. So before preparing a framework, we should know the stakeholders for the disaster management. First of them is government leadership. All the government and the leaders sitting are taking that key position. They are one major stakeholders. Then all the business organization and business leaders, they are one of the key stakeholders. Then every citizen of the world at a social level, at a state level, national level, or at least international level, every citizen is also a stakeholder for the disaster management framework. So whatever framework we are establishing, or the key position holders are establishing, these stakeholders should always be in the picture. Next slide, please. When we are preparing the framework, disaster management framework, this is divided in 4 stages, RIRS. First of all, we need to review the existing framework if it is there. Then we need to identify the gaps in the current scenario. In the same time, we need to think about, we need to be futuristic, and we need to think about possible future instance. And then review all other possibilities which may affect the disaster framework, and then finalize it. Next slide, please. Then key aspects of disaster management. Next slide, please. So there are 4 key aspects which have been identified from the several research papers. So first of them is prevention and mitigation. We should try to prevent disasters as much as possible. And if something occurs, we need to identify the root cause and try to mitigate it so that nothing should appear. First of all, it should not appear at the first instance. If it occurred, then we need to make sure that it should not come next time, or it should not repeat. Then the preparedness, we should be prepared all the times, and this preparedness can be achieved by taking some lessons from the previous experience. Then the third one is response. Our response should be effective, verified, and its psychological and physiological aspects should be verified or should be considered while we are preparing for response. Then the recovery. Quick recovery is very much needed. However, all the time it is not possible to do the quick recovery, but at least we should make sure that recoveries are reaching to the very end, or with like up to each individual at the bottom level. Next slide, please. Now we will discuss about, I will present about review associated factors of disaster management. So in addition of those which I have mentioned in the previous slide, there are some associated factors which are very much needed in this prospect. These are, thank you so much. So these associated factors are, first of all, resilience and agility, which is one of the hot topics nowadays. We need to, all the disaster management framework need to be resilient and agile. It should not be fixed. It should not be rigorous. It should be able to accept all the changes. Then the learning, one of the key essential, all the past events we need to learn, and we need to include all those technological advancement to perform this learning, to fulfill this learning aspect. Then the collaboration. Nowadays, because of the advanced technological advancement, communication is very, very easy now. So collaboration can be done in a more effective manner, and the response of the collaboration should be very quick. Then the sustainability. all the factors which are associated with the disaster management, or all the response, all the plans should be considered by thinking about sustainability. They should be sustainable, and they should be able to give a long-lasting positive and favorable effects, rather than any we have taken the action, and in future if there is some consequences of those actions, these need to be verified. Then our approach should be futuristic. All the key position holders and all stakeholders should think positively about the future and all possible instances or scenarios before finalizing, or before responding, or before reacting to any disastrous events. Next slide, please. Now, finally, conclusion. So in disaster management, we all are responsible for our planet at individual level, organizational level, and national level. So the one of the key element over here is that all of us need to work together, and all the key aspects which I have highlighted in my previous slides need to be considered, and all the associated factors should not be ignored. Whenever a disaster management plan or framework is being established, it is very much important that key aspects as well as associated factors should be involved. Next slide, please. Next slide, please. So here are some research papers. There are many more in next slide. So these are the research papers I have followed for this presentation. Thank you very much.
Deepak, thank you very, very much. You were right.
You're welcome.
You got 4 extra seconds. Let everyone know that if you have a question, one of our today, please put it in the chat room. Address it to everyone so that everyone can see it, and we'll answer them at the question and answer period at the end of our session. Again, thank you very much, Deepak. Our next speaker will be Mr. Jonathan Lim.
Hello, can you hear me?
Hear you fine, Jonathan. Thank you.
Awesome. Thank you. All right. So, hello, everyone. My name's Jonathan Lim, and I'm the project co-lead to JOSAT Astra. So as part of the 2021 IAA Planetary Defense Conference, I'll be advancing the need for a human rights-based approach, HRBA, in shaping disaster management and response as an essential component in the formation of a planetary defense policy. Humanitarian aid options are presented as the result of the interaction between the human rights of peoples affected by disasters and corresponding governmental obligations. The application of HRBA upon humanitarian aid and disaster relief, HADR, highlights the need for states to integrate human rights values and principles across all stages of the disaster management cycle, including preparedness, response, and recovery. The adoption of HRBA safeguards empowers citizens to change governmental decisions which refuse international aid, and places the measures taken by sovereign states to protect their populations in the aftermath of catastrophes under international scrutiny. Accordingly, the integration of human rights values and principles will facilitate the adoption of individually focused safeguards, preserve individual dignity, and promote a more equitable and cooperative environment conducive to post-disaster recovery. Next slide, please. So human rights represent standards that recognize and protect the dignity of all human beings. These rights reflect the minimum standards required for people to live with dignity, satisfy their basic needs, and to take full advantage of all opportunities. Human rights broadly encompass the following principles. Firstly, the universality of such rights. All people everywhere in the world are entitled to them. Secondly, all human rights are indivisible. Deprivation of one right adversely affects the others. Third, the fulfillment of one right often depends wholly or in part upon the fulfillment of others. Fourth, all persons and institutions are accountable to just, fair, and equitable laws. Fifth, all people have the right to participate in and access information relating to the decision-making processes which affect their lives and well-being. And finally, states and other duty bearers are answerable for the observance of human rights. They bear the responsibility to respect, protect, and fulfill the international human rights obligations. Next slide, please. So the formation and enforcement of human rights are contingent upon an established framework codified through a series of multilateral agreements at the international and UN level. This includes the collection of foundational documents under the International Bill of Rights, referred to as such, including the UDHR, ICCPR, and ICES. Oh boy, I think we're at the wrong slide, sorry. Next slide, please. Yeah, that's the right one. Yep. So the UDHR, Universal Declaration of Human Rights, ICCPR, and ICESCR. However, the protection of human rights has not been systematically or adequately integrated as a strategic consideration across contemporary humanitarian analyses, planning, policy, and decision-making fora. Where humanitarian assistance is not based upon a human rights framework, there exists the risk that A, the focus of any relief proposals will be too narrow, B, that the basic needs of victims will not be integrated into a holistic planning process, C, that factors important for recovery and reconstruction will be overlooked. Human rights must therefore comprise the legal underpinning of all humanitarian work pertaining to natural disasters. Next slide, please. So the integration of HRBA across the legal, policy, and programmatic levels of humanitarian action and natural disaster response provides an effective means for operationalizing international human rights law and international agreements. The requirements of HRBA provide for the following several guidelines. Consequently, the utility of human rights lies in its broadly endorsed normative and legal framework, which sets minimum standards for governance and clarifies the rights and duties of governments and rights holders. In the formation of a disaster management and response strategy, HRBA secures the participation of the affected population in preparedness, response, and recovery efforts, ensures equitable access for all to assistance and protection, and acts as a bridging function across phases of a crisis in bolstering interagency and international cooperation. Next slide, please. The application of HRBA is central in advancing the effectiveness of HADR through the prioritization of human rights values and principles, balancing the necessity for humanitarian action vis-a-vis state sovereignty. HADR forms a crucial framework for contemporary disaster response efforts, coordinated through a foundation of principles embedded within customary international law. The founding principles of humanitarian assistance include humanity, neutrality, and impartiality. The application of HRBA can guide HADR actors in the provision of effective and equitable relief. This is supported by the International Law Commission's draft articles on the protection of persons in the event of disasters. Furthermore, noting the military role in the provision of HADR, state engagement in civil military coordination bears the potential for elevated human rights concerns during natural disasters and humanitarian crises. The application of HRBA herein promotes a response centered on the dignity and rights of the individual and precludes potential for abuse of power by institutions, providing effective relief for communities and ensuring that all stakeholders can equitably engage in post-disaster recovery efforts. Consequently, application of HRBA to disaster management and response ties into the right to humanitarian assistance, HRA, in cases of emergency as a product of international customary law. HRA has been implied in the entire system of basic human rights as a supplementary right which serves to ensure the maintenance of associated basic human rights within instances of humanitarian crisis or natural disaster. Such components of the right to humanitarian assistance can include the following. Next slide, please. So firstly, states bear the obligation to respect, protect, and fulfill the right to life under Article 3 of the UDHR, which declares that everyone has the right to life, liberty, and security of the person. RTL provides for the positive duty to protect life and negative obligation to refrain from violating this right. States must also undertake appropriate and proactive measures to prevent harm from and to private individuals or entities. Consequently, across humanitarian action and disaster management, and response, there are many circumstances and situations which present a clear and present threat to RTL. Authorities must therefore take steps to protect persons affected by natural disasters against the dangers of potentially secondary hazards and other disaster risks. Next slide, please. Second, states bear the obligation to provide their citizens with sufficient, safe, acceptable, and physically accessible and affordable water for personal and domestic use. In 2010, UN Resolution 64/292 explicitly recognized RTW and sanitation as a basic human right, declaring that clean drinking water and sanitation are essential to the full enjoyment of life, an adequate standard of health, and realization of all human rights. States must account for several factors in realizing RTW. Firstly, availability, where the water supply for each person must be sufficient and continuous for personal and domestic uses. Second, quality, where the water required for each personal or domestic use must be portable. Finally, accessibility, where water and water facilities and services must be accessible to everyone, being physically and economically accessible without discrimination. Next slide, please. Finally, so concerning RTE, Article 26 of the UDHR states, everyone has the right to education. Children affected by humanitarian crises and natural disasters have the right to education that is free and compulsory at the primary level. Measures must also be taken to ensure education is not disrupted at higher levels as a consequence of natural disasters. Concerning ROP, Article 17 of the EDHR states that everyone has the right to own property and that no one shall be arbitrarily deprived of their property. Within the context of a humanitarian crisis, everyone has the right to the recovery of loss of dispossessed property and possessions to the fullest possible extent. Concerning RTW, under Article 23 of the UDHR, everyone has the right to work, to just and favorable conditions of work, and protections against unemployment and discrimination. Projects to restore economic activities, opportunities, and livelihoods disrupted by a natural disaster should start as soon and as completely as possible. Next slide, please. In the context of disaster management response, therefore, the benefits of human rights in supporting humanitarian action and social development can be viewed through several aspects. Firstly, human rights ensure that every person's need to access elements central to leading both a healthy and active life are provided and protected. This guarantees a baseline level of dignity and existence conducive to security, social harmony, and prosperity.
1 minute,
Second,
Jonathan.
Human rights protect vulnerable groups from abuse and discrimination. And third, human rights provide a universal standard for holding governments accountable. Next slide, please. So given the applicability and utility of human rights, it's advanced that a planetary protection policy, which incorporates disaster management, should consider the following recommendations as part of its elements. Firstly, where the law is the principal basis for effective humanitarian action, protection should be centered on ensuring respect for human rights, humanitarian and refugee law. Second, identify measures to ensure that affected persons and communities are fully consulted and can fully participate in all stages of disaster response. Third, human rights information must be analyzed and assessed in terms of accuracy, credibility, compliance with international law, and use for advocacy to inform concrete action. Fourth, complement existing guidelines on humanitarian standards in situations of natural disaster. And finally, to promote access to justice, including at the national level. Next slide, please. Yep, so that marks the end of the presentation. Thank you all for your attention.
Thank you very much, Jonathan. That was excellent. And I have a couple of questions for you at the end, so stand by for that. Our next presenter is Mr. Chandra Marwash. Ms. Marwash, please proceed.
Okay, so am I audible?
Yep, we can hear you. And
So hi everyone. I am Akanksha and I am currently an assistant professor in Delhi Metropolitan Education, which is a college affiliated to a state university in State University of Delhi, which is the capital of India. And next slide, please. my author, I will be presenting on behalf of my co-author, who is an advocate practicing in Delhi. So my objective here in this presentation is to first, since we know what we have, this is the 4th day of this conference, we know what NEOs are, we know that what their impact is on the Earth whenever they attack, whenever they hit. So my focus would be restricted to the disaster management approaches whenever they, whatever is adopted in the Earth-oriented disasters, which is frequent as compared to the neo-Earth or near-Earth objects impact, and how the approach in the Earth-oriented disasters can be used for dealing with the neo impact, and what is the current development, how far we are, and if we have an event of neo impending to happen in coming 6 months, then what can be done to deal with that. Next slide, please. Next, yeah. So since we know this, I'll not invest much of my time here. So they are asteroids, comets, or let's say for that matter, there is also debris which surrounds Earth, which has the capacity to protect ourselves from that as well. So next slide, please. Next slide, please. So whatever we are doing here, we are doing it in the context of planetary defense and considering Earth to be a common heritage of the entire mankind. My focus would be on the 4 C's of disaster management, where my intention is for the countries to collaborate, communicate with each other, cooperate, and then develop a technology, develop the mechanism with which the entire Earth can be protected. Next slide, please. So if we look at the elements of planetary defense, we can compare them with what elements, what approaches, or the event of flow that we follow whenever there is a disaster, impending disaster, which is there is an apprehension of some disaster. So when we say detection, we know that there are technologies available for detecting or tracking the events that could lead to detection or detection of the of certain disasters like earthquake, floods, tsunamis, or so on. Similarly, we have technology that can track the neos surrounding the Earth. So once we have tracked it, we need to have the technologies to assess the risk, appraise the risk, and as my understanding goes, it can only be taken when we have a long period of time before the neo hits the Earth, so around 1.5 or 2 years. So now that we have 6 months of time, we need to focus more on global collaboration, outreach and education, and evacuation and recovery of the people who have suffered. Next slide, please. Next slide, please. Okay, so a traditional disaster management system, it starts with detection, prevention, mitigation, response, and recovery. The similar way in which we want to deal with the NEOs. Next slide, please. So when we have detected something, we are going to prevent it to happen. So for that, we as we have learned from the last 3 days, that we are developing the technologies like that to deflect an asteroid from hitting the Earth, to change its course, to change its orbit. Within the process of mitigation, we need to analyze what is the amount of risk that we are going to suffer. What is the identification of the risk, the amount of and the quantum of risk that we are going to face. Appraising the risk and working towards minimization of the risk. In the next step, we are going to deal with the preparation. So now that we have 6 months to prepare ourselves, we need to identify the places, ensure that we have sufficient infrastructure to reduce the risk. We need to remove the people from there and take them to some other place which is safe and secure, continuously monitoring the neo which is going to attack the Earth, and provide early warning as much as possible. As far as the response is concerned, once that neo has hit, we need to search for people who might be still stuck at that place, to rescue them and to provide emergency operations. And for recovery phase, that is after it has hit again, to reconstruct that area and to rehabilitate. Again, here monitoring becomes important so as to cautiously reconstruct that area. And in the last three phases, in the first two stages and also in the last three stages, the global collaboration is very important. Now here I would like to mention one thing, that India is now battling with COVID-19, and the situation is really scary here. But the kind of support India has been receiving from other countries who have been supporting us, who have been sending aids, so the same kind of help would be required whenever NEO hits, because right now we're not only talking about one country which is going to get hit, one country which is going to suffer. We are talking about entire Earth. So there is going to be a holistic approach which needs to be taken. Next slide, please. Currently, for Earth-oriented disasters, there is adequate technology, at least for countries who are economically developed or technologically developed. For that also, we need to support the countries who are less developed. But for threats from outer space like NEOs, there is a very less awareness which is available. There are limited plans and policies, and there is the technology is still at very nascent stage. Especially, and when I talk about India, there are only very few policies, there are only very few plans that have been taken. So as far as the preparation is concerned, the preparation facilities are not with every country. Next slide, please. So these are certain things that I could get to know when I was researching for my article, that there are countries like US, EU, NASA is working, ESA is working. But for India, next slide, please. Not much studies have been undertaken. Next slide, please. So India, as far as my research goes, it is not adequately equipped with the infrastructure, the capacity building that we need for responding to any new threat. Next slide, please. So what do we need? First of all, I have little, since I come from a legal background, I have by understanding, I will talk about legal matters, though we have discussed that in day 2. So when we say that law is that tool which can be used to protect and also used to destroy. So I would talk about the collaboration that can be at a global level, and how law can support it to be more binding and all. Here, again, global collaboration and support by the UN agencies who can make it mandatory for sharing of capacities, sharing of knowledge, and communication. That is what we need right now. Next slide, please. So as I was talking about what we need, there are 4 C's of any disaster management plan that we can work upon. We can work upon communication between the most developed nations, the spacefaring nations, and the countries who do not have the technology, but they do run the risk of being hit by a NEO. And cooperation with them, so that it can be globally, it can be at intergovernmental level, then coordination among different agencies. So not only internationally, but nationally as well. Government needs to work with the specialized agencies who can work on technology, providing them funds, and private sector here, where we have been watching private sector growing vastly in space exploration these days. So private sector can also be a great help for providing funding and then collaborating with nations and agencies. So to conclude, I can just say that right now for NEO, not all are prepared right now. We need to have global collaboration. That is one thing I would focus upon, so that we can share the resources and we can protect ourselves. So thank you for giving me the opportunity.
Thank you very much. We are looking forward to answering some questions at the end of the session. Our next speaker is one of our student presenters, and that'll be Miss Anna Ageti. Anna, are you up and ready to go?
Morning, can you hear me?
I can hear you fine, Anna.
Thank you. I'm setting my camera.
And your slide is up.
Okay, good morning, all. It's a pleasure to be in this conference. My name is Ana Lúcia Pegueri. I am a PhD student from Aeronautical Technological Institute from Brazil, and I work in a telecom company in IT area. Well, our intent with this presentation is to bring Brazil to discussions on planetary defense, because this subject nowadays has been discussed mainly at academic level in a few research groups here in Brazil, especially in space law. So this is an outline of the possible actors to be involved in the case of communicated spatial object risk alert. Next slide, please. Well, this is our general agenda, our general topics that we'll be discussing. The next slide, please. So we have made an exploratory literature review to identify existing entities and any existing protocol that could help us in case of a real threat from some space objects. So to help us to evolve communication protocol for exchanging information with Brazil in a way to use technical and scientific cooperation networks that already are established. So we really understand that if there was a need to warn about the occurrence of some catastrophic event, we would not be able to inform international organizations which path this type of information should take to reach decision makers and government agencies here in Brazil. Next slide, please. So in our search, we have found central institutions that are worldwide recognized and represent the mailing existing, how can I say, central sponsors for coordinating activities and research on planetary defense, and that will integrate in our basic model. Next slide, please. So it's important to say that Brazil has relevant space cooperation agreements with many countries, but any of them is specifically to planetary defense. That's is our focus. So, and Brazil is not part of group of nations that composes committees like SMPAG or IAM, and the Brazilian representative we have in this committee is a group of amateurs astronomers from Minas Gerais that somehow have contributed with Minor Planet Center in observing and searching some celestial body for catalog. Next slide, please. So in case of hypothetical necessity of being communicated of an impact warning, our question is, which would be a possible path to follow for the Brazilian government to address the necessary actions in a reasonable time? So we think that the real importance of having an established procedure for international communication is because a government has time to articulate with other federal agencies or other governments ways to better deal with the announced spatial threat, so he can ensure a proper and timely response. Next slide, please. So, since United Nations have recommended the establishment of international cooperation networks such as IAM and SMPAG, we searched for some documents to identify which procedures and actors like international institutions, government agencies, committees, among others, were suggested in the literature. And we have found useful information for our academic work from some guidelines written by NASA, ESA, and SMPAG. So The NASA Policy Directive represents some interesting information for us about responsibilities and some actors that must be informed in case of confirmed threat. The ESA, the Near Earth Object Information Plan, we have been useful to us to identify institutions in Brazil responsible for coordinating actions with local civil defense. And the Planetary Defense Action Plan, as a draft from MISINFORMATION, suggests use the UN corpus as a forum to improving the coordination and the organization communication of space threat activities. So these three documents were used for us. Next slide, please. So in this way, we have complemented the flow and suggest communication protocol based on the similarity of the responsibilities we have found, and not just responsibilities, but roles of some governmental institutions, federal agencies, and other stakeholders. As we know, Brazil today is not a member state from MISINFORMATION, but is a UN state member and have international cooperation with UNOCOPUL since 1958. So we suggest that following the UN communication protocol in case of a credible impact threat, UN would be responsible for alerting the Brazilian government through the Brazilian ambassador on site, who would officially communicate our Minister of Foreign Affairs, who coordinates communication with the State Ministry in the Institutional Service Office, GSI, that given its powers and under its command, would convene the National Defense Council, and what we see that as an articulation entity with other federal agencies, GSI should also be responsible for coordinate communications with SENADE, that I'll talk a little later. In order to follow the communication protocol that already exists here in Brazil for natural disasters alert, we will assume that the GSI, continuing, would communicate the civil house, which is responsible for coordinating the national plan for risk management and disaster response, and is responsible too for interfacing directly with the Ministry of Regional Development, MRD, and the Ministry of Science, Technology, and Innovations, the MSTI. And after that, they addressed for the two specialized institutions to disaster response here in Brazil, SENADE and SEMADEM. So once SENADE receives the information, it's up to it to execute the response plan that is out of the scope of this discussion and articulate actions with SEMADEM and local civil response. What we see that in the need of a response plan for disasters caused by a fall of NEO, it's possible to take advantage of the response plans that are really exist today for natural disasters that can be caused by extreme weather events. But this discussion yet is out of scope. Next slide, please. So now our final considerations. Our goal was to present a model, initial model that could be a start point of a conversation for defining possible points of contact between international entities and Brazilian institutions. And we would like to emphasize that it's an academic approach, and we know that the need for the technicality of several specialist stakeholders and representatives of specific areas of knowledge, such as international law, international relations, public security, public policies, among other institutions. And it would be fundamental and they would be fundamental for the elaboration of a feasible, detailed, and a realistic communication protocol that really meets or directs the mechanisms already established by competent entities that we have today to respond for disasters. So the next slide, please. This is our some articles that we have find out, and I would like to thank for the opportunity. Thank you very much.
Okay, Anna, thank you very much for your presentation. Everybody's presentation today was really excellent. I think we got a great cross-section from our international colleagues on responses to this particular scenario of asteroid impact. We do have a few questions in the chat, and I'd like to start off with the first one, and that's from me to Jonathan Lim. So Jonathan, I just wanted to make sure, you're suggesting that the current disaster response mechanisms do not consider civil rights, human rights during the disasters? And if you do consider that, what is your idea to operationalize it? As a disaster manager myself, I'm mostly concerned about immediate response, particularly in this scenario. We only had 6 months to get ready. There are a lot of considerations. There will be a lot of cascading effects. So I'm thinking that a lot of our responses do have those considerations, but I just want to make sure from your paper, do you think that's not true, and what's your suggestion for fixing that?
So I would say that a lot of states do, but it's a question of sufficiency and what is sufficient and applicable under a state's obligations under international human rights law to respect, protect, and fulfill human rights. And it's about improving state response in that regard. And the propensity for some states to pick and choose which rights they wish to uphold and protect within a disaster scenario is questionable. There's also the issue of certain states not being able to sufficiently support disaster operations, given their different capabilities and how human rights fits into that dimension. And then also the activities of NGOs must be also considered within the alignment of international human rights law, where IHRO is applicable to states. States must therefore also enforce such obligations upon any activities which occur within the disaster management area. And in doing so, states should prepare by setting up a rigorous human rights framework / mechanism, therefore, which includes monitoring human rights violations, investigating potential claims of human rights violations, analysis of these claims, and reporting. And reporting would be, I guess, one of the main points you'd want to focus upon in ensuring the rule of law within a disaster management area and ensuring that vulnerable people have the proper recourse to voice their concerns. I think you're muted. I can't hear you.
Oh, sorry. Thank you very much, Jonathan, for your answer. I think a lot of disaster managers might want to challenge you on whether those considerations are not being taken during their response. Again, the response is really got to be executed quickly, and all your considerations, I think, and at least for the U.S. are considered, and it does depend on the sophistication and capability of the individual nations. So for instance, in the U.S., the non-governmental organizations are integrated into any major responses in the United States because it is a government, civil, military relationship that gets it done. And this would be a very large international event. And I can imagine in this particular scenario for Central Europe, it's even a more complicated issue. For Kansa, there's a question in the chat room with regard to COVID-19 and the perception that more developed spacefaring nations have not adequately assisted those nations. So in your example, for instance, for India, what do you take away as our primary lesson Should you're responding to both COVID pandemic, and if you had to respond to a NEO?
The reason I drew that analogy because COVID also is a disaster for us. If we see the details of disaster, that says that there is serious destruction in the society where human, economic, and environmental, there are losses and impacts, and the society is not able to cope up with them. So the countries came up and supported India only when the situations, except for a few countries, there was help when the situation worsened. Toll was increasing every new day, and the death toll was so high. Even today, we did not expect this to happen in India, especially during the first wave. So one lesson that I have learned that can be implemented is that we do not have to wait for situation to get worse. So this is the reason I said we have to think of global collaboration from the very beginning, so as to not let that thing happen. When second wave had hit India, we could have prevented it then by ensuring that we have adequate medical supplies. We have adequate number of oxygen cylinders, masks, ICUs, ventilators, and other supplies that we need for supporting the population. So one lesson I can say is that we do not have to wait that situation would get over on its own. We have to start thinking and prepare ourselves from the very first stage so that we do not have to see this kind of destruction. So I hope that answers the question.
Okay, thank you very much, Anna. Thank you very much. Anna, for your question, one of our colleagues who's an expert in communications, Dr. Billings, mentioned that the Sonir Observatory is a member of the IWAN, so you might want to look into that for your research. And my question for you is, there are other international disaster response organizations, UN, SPIDER, and other things that could be utilized for international coordination. Is your concern that Brazil or other nations in South America would not have adequate time or get the warning in time for adequate response?
Well, yes, when you talk about Sonir, this observatory is really cited in the paper, but when I said that Brazil had not official representation, when I say official, from the government representation in these committees, and I really will be honest because I don't know about the other countries in Latin America, but in Brazil, I guess that it's an academic view. We should, how can I say, just to define an official way of communicating this kind of problems of war and impact.
Okay, thank you. For Deepak, another question would be also for you with regard to responding in a pandemic environment. The items that you mentioned, do you anticipate that any of those procedures would be changed so that we're in a pandemic environment? Do you anticipate any complications in achieving any of those steps?
Yes, Luis. Like I completely agree that if the framework advised by me is being followed with the proper collaboration by considering all the associated factors, then obviously we are going to achieve all the desired outcome. Now, in terms of COVID-19 pandemic around the world, if we are working with this analogy and we are going to follow this framework by considering all the associated factors, definitely we will be able to overcome this disaster. However, the action plan may not be, because at this process we will continue to learn by our mistakes and by our response, and it may take some time to distribute the response in a right direction. but by implementing this framework, we will be able to overcome this kind of crisis, which is caused because of this pandemic situation.
Okay, thank you very much.
You're
We
welcome.
do have a general comment from one of our attendees that mentioned that these are high-level talks, and at some point, disaster managers would probably need to have some sort of mechanism to bridge the information we're getting from the science community and to the decision makers, to the high-level emergency managers down to the local level, as was shown in one of the presentations earlier. So that is a process. There are some ideas that we need to do. For instance, in the U.S., we do have a national plan, an strategy and action plan that has been mapped out. But some of the details are still being worked out. What is the exact message that's going to be sent to emergency managers? We have the additional problem, as illustrated by our science community colleagues here. In this particular case, we only had 6 months, but we will have a different response depending on how much time we have. If we have no warning, which is still a possibility, then it's a disaster, and we respond as best we can. If it's a number of hours, there's only certain things we can do. If it's a matter of days, there are only certain things we can do. If it's weeks, that's another checklist. If it's months, other reactions. If it's years, completely different response on how we're going to move forward with it. So this is going to be a unique issue for our communities. The science of it is different. Responding to an emergency is generally the same everywhere, and there are mechanisms in place, but perhaps there is some merit to thinking about a specific exercise dealing with some of the details with regard to this type of emergency. So we only have, let's see, we have 5 more minutes. Are there any other questions? Okay, let's see. I don't see anything else on here, Alex. So if you want to give everybody a few extra minutes in their breaks, thank you very much for your participation, everyone. And we hope you can join us for session 10B this afternoon.
Lewis, I have a point.
Yes.
Hello?
Go ahead, John.
Hello, Lewis?
Yes.
Am I audible? Am I
We have
audible?
1 minute. We have 1 minute. Go ahead.
I'm very happy about the presentations, but I saw one point missing. About 16 space agencies are together since 10 years. Over 520 disasters in 120 countries have been managed. So our authors will look at it. Thank you very much. Thank you.
Thank you.
Which is going to be all about providing clear and concise and correct information to the public. And this panel is going to be led by Linda Billings, who we have online here. So Linda, take it away.
Thank you, Brent. Yes, Brent's used some of my favorite keywords: clear, concise, correct, and I've added a couple more: consistent, and definitely in the case of an actual impact threat, timely. They're all important, and it can be done. Clear, concise, correct, consistent, and timely communication can be done. It's not easy. It's not easy. It takes a lot of effort and planning. And I am consultant to NASA's Planetary Defense Coordination Office on Communication Strategy and Planning. This is my 4th PDC, and I suspect, although I don't have data to back this up, that at all of my PDCs, I probably have been the only presenter with a PhD in mass communication. So I have a unique perspective compared to most people in our community. What we're talking about today is reliable communication and dealing with misinformation. And what I've seen over the years in media reports about planetary defense is mostly misinformation, and actually it's more like misrepresentation. We see a lot of misleading framing of our understanding of the risks of asteroid impacts, especially in the more fringy online media outlets, which are proliferating at a great pace. And they tend to slap misleading headlines and leads on cut and pasted versions of stories published elsewhere. Thus far, disinformation and fake news have not been a threat to our community. However, I think there's an increasing need to monitor not only mass media content, but also social media content. And that's a 24/7, every day, all day long, all night long. Somebody needs to be monitoring media content. NASA has an army of mass media and social media monitors on hand to do that, but I'm not sure that they're monitoring the fringes. I just don't know. In the current environment, as I mentioned, misinformation, disinformation, and fake news about planetary defense, if there is any, are annoyances rather than serious challenges. But in the case of an actual impact threat, how would or should communications work? And will misleading reporting be our challenge, or will it be worse? And conspiracy theorists have always been and always will be with us, and they may come out of the woodwork in the event of an actual impact threat. What can the planetary defense community do to prepare for communications in such an event? Who in our community is monitoring conspiracist websites right now? So again, most of the issues that I've mentioned will be a challenge in the case of an actual impact threat. And as many people have mentioned over the course of the conference, NASA, ESA have communication plans in place, as well as IWAN and same page communication guidelines to deal with an actual impact threat. But in the actual event, how would all of this work? We have a great panel for you today. We have three people who will provide very different perspectives on communication issues. Leah Nagel is a graduate student in the Department of Communication at the University of Vienna, where she's studying communication aspects of risk prevention and catastrophe management. Kathy Rowan is a professor emerita of communication at George Mason University in Virginia. Her research concerns the public relations challenges of earning trust and explaining complexities in risk and crisis communication contexts. And she teaches public relations, science communication, and crisis communication. Kathy also will be participating in the panel that is following ours. Sarah Scholes is a Denver, Colorado-based freelance science writer, contributing writer at several magazines, and she actually has an upcoming piece for Scientific American magazine about planetary defense. She's the author of 2 books, and in previous lives, she was an associate editor at Astronomy magazine and a public education person at the National Radio Astronomy Observatory in Green Bank, West Virginia. So Leah, you are up.
Can you hear me?
Yes.
Okay, perfect. So thank you for this introduction. I shortly introduce myself. I'm Leah Nagel, a 27 student at the University of Vienna and member of the Austrian Space Forum. And as I have less practical experience, I'm really thankful for sharing my ideas today with you. And I hope I can give you an interesting input. And of course, I have a more European perspective. And I want to use the next 8 to 10 minutes to go deeper in one specific communication technique, which so I think can be very beneficial in terms of misleading information, fake news, conspiracy theories towards a possible asteroid impact. And this technique is storytelling. And to make it clear from the beginning, I'm talking about multimedia visualized storying using pictures, sounds, etc. And as my background is not only communication science, but also risk and disaster studies, I was always forced to think them together with a focus on natural extreme events. And what I saw over the last years and months, and I think Linda mentioned it also, is that trust in legal authorities, politics, traditional media is decreasing. And in times of social media, the thinking or presumption of control over communication is not working any longer. So this control has to be replaced by another form of guidance. And the present situation, and I'm talking, of course, of COVID-19, is a good teacher in this case. And in future, confidence, reputation will be essential for communicators at any level, to scotch rumors, false and misleading information. So what is storytelling, this technique? Basically, it's telling about a story. And as I mentioned before, I'm talking about multimedia communicated stories adaptable to the new communication channels and environments. And storytelling is used for many years from companies and was commonly discussed in management and organizational studies. So it was more in the business section, but gains increasing attention also in risk and disaster communication, or topics like climate change, nature prevention, earthquake behavior, and so on. So storytelling is therefore nothing new or just a management fad. We all know stories, and this is kind of a special feature because storytelling is fundamental to all nations, societies, and cultures, what makes it adaptable to different communication environments. So what are the basic arguments and benefits of using storytelling as a communication technique with regard to planetary defense and determining misleading information? First, stories are commonly used for abstract, invisible, complex topics because it enables to wrap facts, make them easy to grasp, so to make them digestible. And second, stories stick in the mind more than written materials. They help us remembering facts and instructions. They help us learning. And third, they help to adapt to changes. And in this, they can provide a form of sense-making in disruptive, transformative times. And they can facilitate understanding of dramatic situations. And research found storytelling to be far more convincing than only providing rational arguments, statistics, or facts, because people have an inherent, or some call it bottled up, need for information and understanding. So if they don't know what is going on, they make or will make their own stories. Therefore, if you only organize press conferences, show statistics, give rational data, people or also media agencies, journalists may create their own stories out of it. And of course, this is not harmful per se, but it can be, especially in times of social media. But if you, as a communicator, connect with your audiences due to stories, you can also take a kind of control or better leadership over narratives in crisis situations. So how can you do that? Because this all may sound easy, but there are basic aspects you have to consider as a storyteller, regardless whether you're an emergency, political, or scientific institution. Essential values of effective storytelling are transparency and authenticity. And we all know that in times of social media, an image or an institution's credibility can be destroyed within 1 or 2 minutes. And I think this is not worth the risk. And so if there's a problem, the problem is in the foreground. You then offer solutions, show how you try to overcome and deal with it. So you face the problem, you're willing to understand the problem and show empathy. And maybe this includes also showing how you struggle or showing how people struggle. And basically, it's not advisable to tell stories which are too big. If you take climate change, for example, communicate people what it means in their everyday life, what they can do, what you are doing as an institution. So break it down, make it digestible. Stories connect with people, inspire action, and change attitudes. And I personally find it really important to mention then that to tell stories is not manipulating, lying, or kind of a tinted glass. Of course, you are more or less communicating with emotions, but they are not, we call it a devil in person. On the contrary, they can be very helpful. For example, humor is a emotion as well, and I really like and appreciate humor. Of course, it depends on the purpose and the communicator, and of course, stories. So I mentioned the tremendous importance of transparency and authenticity before. And in this, real stories are often the best stories. And here I now try to come to the full circle. Storytelling works at the roots of misinformation, conspiracy theories, or fake news. First, as a part of prevention, they help us on a long term to build up reputation, trust, strengthen connections to people and organizations, change attitudes and behavior. And second, in an actual threat of an impact, in providing guidance and support in this terrifying situation and marketplace of opinions and information that will come up. And stories can create then a form of sense and understanding, and this is crucial, inspire action and willingness to follow instructions. So this was only a basic overview, but to be honest, I was very unsure to bring up this topic in this context because I'm a student and not an expert in this field. But personally, I really think that communication in the modern world is crucial as well as threatening, especially the speed, the dynamic, the complexity of how obstacles, rumors, and fake news spread, and that people really believe it. And we are talking here about planetary defense and a possible strike with Earth. And this is really serious. And I think we have to work more interdisciplinary. And I don't know if a technique as storytelling is a silver bullet, but what my point is to think outside the boxes we're used to, try new techniques, losing the fear of using emotion in communication, especially for serious topics, and especially on the long term, because the communication environments will continue to change. And providing trustful information to people, the media and societies as a whole will be essential in future. Yeah, thank you.
Thank you, Leah. That was wonderful. And Leah's raised some really important points, particularly something she mentioned at the end of her remarks, that the communication environment will continue to change. 20 years ago, we didn't have to worry about social media, but now it's dominating the communication environment, and it is active 24/7. And she also mentioned the power of narrative. And there's a considerable body of literature developing narrative theory and explaining how powerful narrative has been throughout human history. So thank you so much, Leah, again. And next up is Kathy. Kathy had some slides to guide us through her talk. So Peter, or whoever's on the end of slide showing, can you cue up Kathy's slides?
Thank you. Thank you so much, Linda, and thank you, Leah, for your presentations. This presentation is called Reliable Risk Communication, the 5 W's of Effective Warnings. Next slide, please. Here's a story. In July of 2005, I spoke to emergency management officials in the New Orleans area, Southeast Louisiana, about preparing residents for evacuation. I did so because meteorologists in that year were saying we were going to have a heavy hurricane season. The focus of much attention at that meeting was residents who were upset about the evacuation plan because you can't have every single person on the road at the same time exiting a large metropolitan area. The emergency management officials were asking that some neighborhoods leave during the day, but others had to leave at night. And so many people were complaining that they really did not think they could evacuate at 3 in the morning. I am sad to report that most of our conversation, or much of my conversation that day, focused on how do we deal with those upset people. I was particularly pained when in late August 2005, Hurricane Katrina arrived. Over 70% of the people who own cars were able to evacuate safely. Many others did not. The lesson we learned was that we failed to listen to the vulnerable, low resource households. Next slide, please. That is, our advice was sound, evacuate, but we failed to listen to the logistical challenges of the low resource, the hospitalized, the elderly, agricultural workers who had hundreds of animals to take care of. Next slide, please. Story 2, in September 11th, 2001, as this photo illustrates, planes hit the World Trade Center in New York City. We learned after that horrible day that some use the rate at which water flows downward in a building to estimate the time people can walk down dozens of floors in an emergency. We all know water is not a good model for human beings. When we are warned about a danger, we look out the window, we talk to each other, we question the warnings. We talk, or what disaster sociologists say, we mill. That is, we try to confirm the danger. Next slide. A major roadblock to protective action is the deeply held belief all human beings have that we're basically safe and that we will find information to confirm our basic belief. We have a tendency to deny or reject people who tell us otherwise. Experts, such as the people at this conference, learn to use probability to guide behavior in disasters. If you're not an expert in the particular danger, such as an asteroid strike, the question you're asking yourself is, do I have to do something or not? Next slide, please. According to research, then, what we most need to do with an effective warning is ask ourselves, what is our goal? And we think of the goal as sparking protective action, but the most important goal is to spark talk among the vulnerable people. People have to talk in order to figure out what to do. So what are they going to talk about? That's the second W. They need to talk about how they are going to prepare for this dangerous event. How will they protect themselves? So it's very important to learn about the asteroid strike. It's very important to learn about what officials are doing. But most important is the information about what we all can do to protect ourselves. We're most apt to take that action if we see other people around us doing the recommended action. We're wearing masks, we're packing, whatever the recommended action is, and we're talking about getting ready. There needs to be preparatory work in order to get us to talk effectively. If we have time during discussion, I'll talk about deliberative meetings. That's an excellent way before a bad thing happens to listen to the logistical challenges various vulnerable groups will have and learn what we can do to assist their protecting themselves or evacuating themselves. Next slide, please. So let me review. The content of the effective warning absolutely says what's happening, what the officials are doing, but most importantly, it says what we, the people who are likely to be harmed, can do to protect ourselves. It lets us see, as this photo does, other people getting ready, and it encourages talk about all the reasons why we will struggle with the getting ready part. We will worry about the cost. We will worry about what we're losing. We need help having those conversations. Next slide. The last two W's are the when and the where. The problem with the asteroid strike is we don't know exactly when, exactly what, or exactly where, but we do know how to prepare for these situations, and we know the experts agree that we need to get ready earlier rather than later. So we need to communicate a lot, jingles, conferences, holidays, and we need to communicate in familiar places. So if we're trying to help vulnerable groups get ready, we need to encourage talk in their homes, food stores, barbershops, religious gatherings, social media, television, schools, and videos. Let me stay on this slide one last time. My students, I gave this presentation in class last night, and they gave me a very important point. They said I left out a really important point, which will be discussed by Sarah in the next presentation. And that is, what happens if the talk goes awry? And they're not talking about how to get prepared, but they're talking about whose fault is this asteroid strike and who should we blame? Well, that is inevitable. And so what we need is feedback loops and trusted sources within vulnerable communities, perhaps religious leaders or teachers or other people who can help who can create a feedback loop to give accurate information. Next slide. So in sum, the best warnings are in some ways like the best ads. They're researched, they're accurate, they're respectful, and they say what to do to protect ourselves and others, and they're repeated frequently, especially by vulnerable groups, with the addition of feedback on accurate information, which the next presentation by Sarah will discuss. Next slide. There's a large literature on warnings that you can find, and I'm happy to send slides to anyone who's interested in this. And last slide, please. Next slide. And there's also a lot of research on this topic at the U.S. Federal Emergency Management Agency site. Here are some links. Thank you so much, and I look forward to our next presentation on addressing misinformation.
Thank you so much, Kathy. That was wonderful. And Sarah's up next.
Hi, thank you, Kathy and Leah, for your comments, and I assume that we can all hear me okay. Let me know if that's not the case. So in an emergency situation, and also just like on a regular Wednesday, a journalist's role is to accurately convey both information and context, and to provide readers or viewers with the tools and the expert analysis to understand and interpret what's happening in the world around them. You live in the world, so you know that's not how things always go down. I'm sure you've seen hundreds of headlines that make you roll your eyes, or read dozens of paragraphs that you know misrepresent the facts. And that is, of course, even more likely in an evolving and uncertain situation, because in that case, journalists should not represent the situation just as it is right now, which is hard enough, but present the very fact that it is evolving and uncertain. And when we're talking about a high stakes situation, like a real world impact threat, that's a really rocky news environment. And three kinds of difficulties tend to emerge in such news coverage. The first of which is misinformation. And that is when incorrect information or context spreads, not necessarily with the intention of portraying something false. And I found an example headline from a website called IGN. NASA has confirmed a potentially hazardous asteroid is hurtling towards Earth at an incredible speed. And in this example, we have a news outlet saying something that was technically true. An asteroid technically categorized as potentially hazardous was heading in the general direction of this planet at the pace of, something in space, but the context it suggested was very misleading. Misinformation, though, is different from disinformation. Disinformation is wrong information with the explicit intent to deceive and spread falsehood. An example of this that I found is when in 2014 there was a user on CNN's crowdsourced news site who posted a completely made-up story about an asteroid impact. It said, "Scientists at NASA's Jet Propulsion Laboratory have detected a large object the size of Manhattan, possibly on a collision course with Earth. The asteroid is calculated to have a potentially lethal encounter in March 2041. Astronomers have placed the odds of an impact at 1 in 2.04. Such an impact could potentially end civilization as we know it," which is very scary, but you don't remember it because it wasn't true. And the difference here is that the real information wasn't incorrectly represented, but was in fact fake with the intent to spread falsehoods. And the third problem is lack of information, which the other panelists have mentioned, just that in a potential impact scenario, we won't know things with certainty. Some things we won't know at all, and information will evolve, and that is a very hard thing to portray. And those three problems, I think, can lead to further ones that journalists shouldn't really be in the business of, but sometimes are, which are hype, fear-mongering, or, on the other side, downplaying what is actually a serious situation. So how can my people in the media avoid falling into these traps? And how can public agencies and scientists help? First, I think it's important to look at the way that most journalists will find out about a potentially hazardous situation, which are press releases and press conferences. Most regular people will get their information from our news coverage, not from the press release or conference itself. So I think it's important for agencies and communicators to frame information accurately and provide enough information that journalists can do their job well. One important thing to consider is the influence that a headline or an email subject line announcing the press conference can have on a journalist's story. The way official communications are framed can influence the way journalists, especially those who are on very fast deadlines, will cover it. So when you're writing things, consider whether the top line of your communications would look well if someone splashed it verbatim on the front page of a newspaper. After those basics are in order, I think it's important for official materials to provide background necessary for journalists to do more than simply rewrite the press release that was given to them, but to look into it themselves and so relay to the audience why they can trust the information and what uncertainties or contradictions might exist. Related to that, I think it's really important to make sure that experts are available for interviews. A lot of times, especially at government agencies, there is a long and bureaucratic approval process before a journalist is allowed to talk to a scientist or communicator. And the reason we want to speak to experts before we write our stories is not to, do a gotcha, but to get the story right, to learn, for instance, why and how follow-up observations will help us learn about an asteroid's probability of impact or size or things like that. And when a story can include quotations and context directly from experts and not just from our words as journalists, readers tend to trust it more. But if we can't speak to someone who knows what they're talking about before a deadline, a lot of times journalists will go on what they have or reach out to whoever happens to be the loudest voice on the internet and seems to know what they're talking about. And you've met the internet, so you know that's not really often good. And I think it's also important to be transparent as new information comes in and old information changes. To take a lesson from the pandemic in the United States, we heard a lot at the beginning, only medical professionals need to wear masks. You don't, it won't help you. And I think that led in part to some of the public mistrust of mask guidance that we have now. The final thing in terms of what journalists can do, I think, is to look at the responsibility not to overload readers. And here I thought about the pandemic again. I think we saw people succumbing to news saturation, where we just heard so many alarm bells for so many months that what people wanted to do was escape from information, not know more. And to combat that in a planetary defense situation, I think we could cover the latest reliable information as it comes in, but maybe not recycle it on the 24-hour news cycle that we have. So say something once rather than saying on Monday, this asteroid could destroy a city, then publishing a graphic on Tuesday that lets you simulate your city being destroyed, and then on Friday publishing this human interest story about the prepper guy down the street. And I think it's important within that to give readers or viewers ways to feel empowered, like there's something to be gained or done with their knowledge, like laying out mitigation plans and progress in understanding the situation. And in the last minute or two of my talk, I'd like to talk about combating bad information once it's out there, because as we all know, it absolutely will be. We know from other contentious and high-stakes fields like climate change or vaccination that debunking myths doesn't always work, and in some cases just entrenches people's existing incorrect beliefs. So in this part, I'd like to focus on a few alternatives to just debunking. And the first thing that I think is important for journalists is to not elevate conspiracy theories that haven't yet gotten widespread buy-in. So like if a low-level blog publishes the idea that like an alien civilization is sending an asteroid our way, a journalist doesn't need to write a story refuting that. Rather than changing anyone's mind about the aliens, what you'll do is just cause more people to hear about it. And from the communication side, I think that you can proactively reach out to reporters at publications that maybe have a less than stellar reputation, the places people tend to go for tabloid news, and then tell those reporters the real story, and then, I guess, cross your fingers. And the last one that I think is important is to immunize people against misinformation in a process that researchers have started to call pre-bunking. So telling people about misinformation they might hear before they hear it, then tell them how and why that information is false and how the falsifiers might attempt to get buy-in. So a journalist could say, for instance, you might hear that scientists have known about this asteroid for years and just kept it a secret from you so you would panic. But here instead is why no one was able to find this object before. Here's why and how they found it now. And here's how the open culture of science and data works. And so just to close, I think that, the modern news landscape is absolutely full of landmines, but we're lucky that we have time to figure out how to navigate them from the planetary defense perspective before we're actually in a real world scenario. And I will turn it back over to Linda.
Thank you so much, Sarah. Like our other two speakers, you've raised a lot of important points, and I have recently been reading about this idea of pre-bunking, which is, tell the story straight if you expect that it might get twisted down the road. Pardon me here, we've got a lot of activity in the chat, and my computer keeps sending me to the bottom of the list, but I want to start at the top of the list, so I'm going to take a couple seconds here to get back to the questions. Okay, I know the first two questions were, oh gosh, excuse me, were somewhat related. So I'm going to read them together if I can ever get back to the top of the list here. I'll just mention that I've been attending the conference throughout the week, and the importance of communication has come up in several sessions. But again, we need more people who have expertise in communications working with the community, people like Leah, who will soon be an expert. And oh my gosh, this is just crazy, this scrolling thing in the chat. I'm sorry, I apologize. Let's see. Okay. Nope, I'm not quite there yet. Gosh. We've had quite a bit of comment from Jana Tisha at CLET Observatory, and she's put a citation into the chat to a paper she's written, so we can look at that. Okay, here's the first two questions that are somewhat related, and I had the same thought listening to Leah. In a crisis situation, particularly on a global scale such as this, how do you ensure your stories and narratives are heard amongst the considerable noise? And also, Leah, for Leah specifically, can you give examples of the sorts of stories that are productive or counterproductive in an impending natural disaster situation? And of course, we've seen during the pandemic that we've had, reliable narratives and counterproductive narratives competing for attention. And I think over time, the reliable narratives have taken precedence, but for a while and in certain places, that was the problem. So, Leah?
I think it's really, really difficult to answer because it completely depends. Good stories, I think, try to use the speed and go viral and spread without doing a lot. But actually, I can't give you a satisfied answer, because I think the best way is to start to set up communication strategies, is to recognize the complexity and uncontrollability of the modern communication environment. And we have different national media systems and a global communication environment. So there is no easy answer or no silver bullet how to do a global, reliable story.
You're right, it's a challenge. Yes, Absolutely. And something you can continue to look at as you continue with your studies.
But sorry.
Yeah,
I think I forget because somebody asked if I can give examples of sorts of stories. And I think, and I mentioned that the real stories in crisis situations, I think it can be very beneficial to talk to the people and that they will maybe offer you a story. And that's what I meant with real stories are the best stories. You don't have to think about a story. The story comes to you. Yeah.
Yes. And Leah, I hope you've noticed in chat that NASA's Planetary Defense Officer listened to your talk and he would like to hear more from you. He found it very interesting and informative. So that's good news. And I'm glad you've joined our planetary defense community. Here I have to scroll up again to the beginning of the questions. Okay. There's some discussion in the chat about edutainment, educational entertainment. And there's the good, the bad, and the ugly in my experience in the edutainment arena. But if it's done well, it can be useful. And there was a comment to that effect. Let's see. There's another question. Is it appropriate for a committee of scientists to advise the international press to avoid false news, very frequent in disaster scenarios? Well, I will mention before the panelists want to respond, but this is what the International Asteroid Warning Network is trying to establish itself as doing. So, so far so good because we haven't had an actual impact threat. But again, things will change in the case of a threat. Does anybody else have a response to that question?
Linda, could I just add one point? I think, let's see, I see toward the bottom of the chat, Lord Dover in the United Kingdom is saying that essentially they've made efforts in their National Health Service to reach out to vulnerable groups and minorities to learn about who are the influencers in those communities. So one way to say that is they created a feedback loop they listened to the vulnerable people to find out who they find influential. So if it's possible to take stories, as Leah said, that are emerging from those groups and to have the influencer encourage the stories that encourage protective actions, then we're encouraging the kind of talk that we want to take place.
Yeah, very important points. And Leah mentioned the importance of empathy, conveying, not just conveying empathy, but having empathy, really listening, not just talking, but really listening. And I know, Kathy, you're familiar with the work of Peter Sandman, and he always stressed the importance of acknowledging people's fears. It doesn't work in a crisis situation to tell people, don't worry, we've got things under control. That is not a good message. So, okay, I'm still scrolling through questions.
Could I add something about the international press?
Yes.
Yeah, so I think that most journalists, at least reliable outlets, don't want to provide fake news. We would like to get the information correct, and so I think maybe rather than advising the international press on how not to provide false information, framing it as here is access to the good information. Here's where you find it. Here's who you can talk to. Here's what we know, here's what we don't. And I was thinking about this earlier, and I think a good example, this is not an emergency, but recently NASA landed a rover on Mars. And in advance of that landing, they provided like a 72-page press kit with answers to every question that someone might have and where to find more information and who to talk to. And I know that, in an impact threat scenario, you probably can't write a 72-page document before you get in touch with someone, but just knowing where to find the good information, I think is very helpful.
That's a good point, Sarah, and you'll be pleased to know that we are at NASA, are already at NASA in the Applied Physics Lab, working on a similar press kit for the double asteroid redirection test. So you will get many, many pages about that. Everything you need to know. I think I've gotten most of the questions. If I've missed, because there's a lot of chat, as I said, and there are a couple of people who've been talking about social influencers. And I think Kathy mentioned that in her remarks about the need to get out into the community, in barbershops, in churches, in schools, trying to get out messages. And LA, you asked, where can you find information about pre-bunking? I will send you some references. Go ahead.
Well, now I missed the point. It was, influencer. I want to talk about influencers. As I mentioned, the traditional media, the authority also of organizations is decreasing. So I think it can be really, beneficial to also like strengthen connections to reliable and trustful YouTubers or like other opinion leaders, and not just maybe one organization, because on YouTube or in Instagram or they have like 2 million, 3 million followers, and I don't know the government in Germany or Austria is like 100,000, 200,000. So, yeah.
Wow. Yeah, very interesting. There is another question about movies about asteroid impact disasters. And is there any movie that seems to be more accurate, even though all these movies are fictional, than others? And Lindley Johnson's favorite asteroid impact movie is Deep Impact. So we all like Deep Impact. It's one of the better ones, but there, in my eyes, it's still a lot of not realistic stuff going on there. I, for one, my colleagues don't all agree with me, but I, for one, am sick of hearing references to Bruce Willis in stories about asteroid impact hazards. But again, my colleagues feel a little bit better about that.
Linda?
Yes.
This is Bill Ayler. I just wanted to tell you that I went to see a movie that on IMAX that's coming out very soon. It's called Asteroid Hunters. And I think you'll really find that is quite a good movie. It's very factual, lays it out very much, in a very accurate way. So I think that'll be a good one when it hits the streets.
Thank you for mentioning that, Bill. I should have mentioned it myself. We actually have I've seen the movie. It's very good, and all of my colleagues on the planetary defense team at NASA agree that it's very well done. And Phil Groves, who's been in the session and in chat, has been doing research on this film for years and years and years. Did a good job, and we actually have a screening at a theater in the Washington, D.C. area today. And there's another question here. What about popular scientists and science types? Do they have a role to play? I'm thinking of Brian Cox, David Attenborough, Carl Sagan, Neil deGrasse Tyson, etc. Of course, they could have a role to play. And Bill Nye, who's a very popular guy, and particularly younger people really like Bill Nye. And he is totally informed about NEO observations and asteroid impact risks. So, and he will be participating in the public program that the Planetary Society is holding online for us later today. And we have had, I will mention one public scientist, talking head scientist, Michio Kaku, who I can't remember the circumstances, Lindley might remember, but he made some remarks in a television interview that we felt misleading, and we actually contacted him and sent him, a better framing of what he was talking about. And as far as I know, he didn't respond, but we tried. I'm trying to see if I missed any other questions here. I appreciate all the comments people put into the chat. As far as I know, and Romana, correct me if I'm wrong, but chat content will be saved, so we can go back and look at these kinds of things.
Yes, indeed, Linda. It will be.
Yeah. Panelists, do you have anything else you want to say? We have a few more minutes, about 3 more minutes. Yeah, Kathy.
I want to just pick up briefly on Sarah's important point about pre-bunking. I noticed a lot of comments about that. It really is a very interesting literature. And just to give one more example from that literature, people like to know, they like to be in the know. They like to be able to spot misleading information. So one other pre-bunking approach, and Sarah can elaborate on this, is to sort of show people the technique in advance. So one common technique is you find one person who's with a paid association who's putting out false information, and you say that person equals thousands and thousands and thousands of scientists who studied the issue and had to write papers that were juried by many other people to see if they were true. And so you're creating a false equivalency. And essentially you say to people, you don't want to be lulled by a false equivalency. You know that it's hard to figure out what's true. And so you want to go for the people who worked hard and had their work vetted. So essentially what you do is you try to alert people to the technique so that it doesn't catch them. And I'm sure we can all think of misleading techniques from all sorts of sources where you essentially call out the technique first and demonstrate it. And I know Sarah knows more of this because she spent time going through that literature.
Yeah,
oh, sorry.
Go ahead, Sarah.
That's a very good point. And I think something that's important to keep in mind about the people who might be misled by fake news or conspiracy theories is that they don't want to be anti-science. They are trying to figure out the answers themselves. And so when you empower them by showing them the rhetorical strategies that other people are using to find out for themselves, then I think a lot of people will naturally go more toward the true information. And I think my one final comment related to Kathy's comments about vulnerable populations, I think something journalists can do is write stories specifically geared toward the concerns of those populations. Like for the evacuation case, how do you evacuate without a car? What are the best ways? And not just writing for the upper middle class people, but writing specifically for certain other populations.
Yes, absolutely.
Very good. Well, actually, we have 10 more minutes. I was mistaken. We have 10 more minutes.
Yeah.
I wanted to mention something that has been brought up. I think Kathy mentioned it explicitly. The need to humanize our stories, the need to humanize our narratives, to make them. I'm fascinated by television ads for prescription drugs, where it's a drug that's supposed to help you deal with, or perhaps even cure, usually manage potentially really bad disease. And of course, it shows the people who are using this medication happy and healthy. They're always good looking, and they're usually outdoors having fun. And it's a way of saying, if you have diabetes, you can still live a happy, healthy life if you use this medication. I find that, and it's a very common for advertising prescription medications. I'm looking back in the chat, lots of chats. And Joel, I understand your concern, and I apologize for the time I've had to waste scrolling through comments. Next time around on a WebEx meeting, I will figure out how to deal with that problem. But I should mention also that throughout the PDC this week, we've heard a lot of references to what we've learned from the pandemic. There's been some discussion in this session about it. There will be more discussion. I think there's actually a whole panel tomorrow. I'm not sure because I don't have the program up in front of me on lessons learned from the pandemic. There'll probably be some discussion of that in the next panel where Kathy will be participating. And I've collected a huge body of literature, both peer-reviewed published literature on pandemic communications, and also stories from the mass media and some science magazines about lessons learned about communications during the pandemic. Yes, Kathy.
Oops. Oops. Just a brief comment to follow up on the point about humanizing the story, Linda. I was just thinking about, I wish back in 2005 we had done heroism stories among the vulnerable groups. So who are the influencers in vulnerable groups who are helping one another? You know, who are those people? And recall that upsetting photo I have of people in a vulnerable situation wading through terrible, you know, waist-high water. You know, where are the great photos of the heroes in the vulnerable groups? And how might we do stories about, you know, the farmer who figured out how to save, you know, 100 head of animals? Or how might we do a story of vulnerable groups who figured out how to rescue their family in a difficult situation? So anything that would tell that story and give efficacy to those people would be helpful in a dangerous situation.
Yeah, all good points. All good points. How do we deal with the translation of information? Oh, this is the question from Alex, and its accuracy in case the threat is located in the part of the world that has only limited, if any, knowledge of English. That's a really important question, and UN-USA is dealing with the need to translate all the information that UN-USA is putting out, publishing on the web, so to speak, distributing in the 6 official languages of the United Nations. And that's only 6 global languages. And I learned recently in reviewing a paper for a journal that in Nigeria, which I believe is the most populous nation in the African continent, people speak 500 different languages. So how do you communicate effectively about an impending disaster when people are speaking 500 different languages? And in some countries, you also have different levels of literacy, whatever your language is. And I remember years ago doing some research about communicating with rural Indian families about family planning. And most of these people were not literate. So it had to be storytelling, like in-person storytelling with pictures, things like that. So we have all these different tools to use. And we have another question. Can some public see storytelling as a spin doctor? Does it mean one should avoid officials? It's an interesting question. Anyone want to comment on that?
Well, I think spin doctoring is more manipulating, and I think storytelling, or what I wanted to mention, is that storytelling should be used from officials, not from I don't know who, but that these institutions should use storytelling. Did I get it right? Or
oh, that sounds good to me.
I'm not quite sure whether I get the question right.
Well, you mentioned, Leah, in your remarks, the importance that stories, narratives need to be transparent and they need to be authentic. And so, yeah, we're all used to spin doctoring stories. So that's more of a problem in the world of politics than it is in the world of science, I hope. But yeah, the stories need to be real. They need to be real. And I think all of you have mentioned that one way or another. You know, they need to be believable. We're not trying to persuade. We're trying to inform. And as Leah mentioned, the aim is to prompt people to inspire. I think you used the word inspire people to take action if they need to be in the case of disaster, an impending disaster, to tell them. And I think we all have mentioned one way or other, we need to keep telling people what they can do. We need to tell people what we know, what we don't know, and what they can do. That empowers people to take action.
I think also that officials can help journalists find stories, so that sometimes the stories aren't coming directly from the officials, but are going through the media, and storytelling is, you know, our whole job in a lot of ways in portraying accurate information. And so it might come across as a little less spin if it comes from us. I also saw that there was a question from Mark Boslow, and apologies if I'm mispronouncing your name, that I am interested in the answer to. I don't know if you can see that one, Linda.
If you can see it, go ahead.
Oh yeah.
We can answer it.
Can you comment on one barrier to rapid response debunking of fake news and hoaxes? There's institutional inertia that slows down the ability of NASA or national lab employees to respond quickly, because many times we're subject to rules for review and approval by management of anything we say. And as someone who's often trying to get access to NASA or national lab employees, I'm interested in what the rest of you have to say about that.
Yeah, that's a good point. And Mark, we probably had conversations about this before, but debunking is not an effective communication strategy in the long term, because I boil it down to this strategy. I'm right, you're wrong, here's why. And debunking is not particularly effective because you're telling people they're stupid and you're smart. And it can turn people. It can actually harden people's beliefs in that you're trying to debunk, and which is why this literature on pre-bunking, this different strategy, proposes that pre-bunking is more effective. Have a couple of minutes left. Any more questions?
No, I just want to raise again the point of interdisciplinary work, because I think also communication shouldn't be done only from communicators, but I think also psychology, sociology, and maybe urban planners also, when you think about how to reach vulnerable groups or elderly people. So I think this is really, really important to work broadly with other disciplines.
Very, very good.
I
Thank
agree
you so much to all the panel.
And now I'm going to be turning it over to L.A. Lewis, who's going to be leading our panel session today about lessons learned from past disasters and recommendations for a real NEO threat. L.A., the floor is yours.
Thank you, sir. Good morning, everybody. Welcome back to the Disaster Managers our panel. Today, we're going to talk about lessons learned, and we have some distinguished panelists. Two of them are rejoining us from yesterday, Einar and Cerise. So I'd like to give my co-panelists, co-lead this evening, the first hit at what we're going to discuss this morning. So just in general, to give everybody an update, what we did is we want to talk about general lessons learned for disasters, particularly in regard to what might be happening during a NEO event. We had our overview has about 4 issues. What has the COVID-19 experience taught us? Is there relevant experience for planning and for and responses to hurricanes, earthquakes, and other natural disasters? Is there a relevant experience from disaster from man-made events, such as nuclear power plants, chemical plants, et cetera, and how has the public reacted in the case of past disasters? So how I'd like to do this is a round robin, similar to what we did yesterday. Started off with my distinguished colleague, Mr. Sharice Ravan. He coordinates the activities of the United Nations Platform for Space-Based Information for Disaster Management and Emergency Response Program of UN Office of Outer Space Affairs. Take it away, sir.
Thank you, Ele. So probably we can build on what we discussed yesterday, and also today the disaster management session that we had. Several panelists talked about fundamentals of disaster management and international cooperation, and we just talked disaster communication just now, or disinformation. Of course, the entire scenario and exercises that we did, and there was wonderful discussion. I think what Elia says, I can just support that today we can focus more on how responses to past low likelihood, high consequence disaster might inform actions should really a new threat be discovered. I mean, in general, we disaster managers, they deal with the frequently coming disaster. These are floods, droughts, cyclones, storms, earthquakes, landslides, also some of the man-made disasters like probably oil spill in the ocean and those kind of things. But opportunities to deal with low likelihood disasters that can have very high consequence, like COVID just now. We don't even know that if we can call it disaster or we call it humanitarian crisis or whatever it is. But this is one of the things where in many countries, disaster management law has been activated to deal with the COVID crisis, the pandemic. So, so there are several like that. Probably the cities that are sinking, and that has long-term impact on disaster. That can also trigger some disasters, land subsidence, or the glacial lake outburst floods. We don't listen about it many times. I mean, this happens once a while, but the consequences are very, very high. So I think that particular experience of those kind of disaster, which has rare, low likelihood but high consequence, that is very applicable for NEO threats as well, because we have not seen NEO threat so far in real life, but now we know the objects are coming. We did this particular scenarios, and we did the exercise. So I think we can build on that lesson and relate it to how, if such impact becomes real in future, how we should be very well prepared. That probably things that we can see. I will come back again. Probably you would like to take over to call the speakers, or shall I do that?
Why don't you go ahead and do that, Suraj?
Okay, then let me just look at the agenda. Right, so we have, give me a minute, I have to look at where is the list of. Right. Okay, so we have a first presenter or speaker who will give us insight about on this particular topic. Mr. Einar Virgo. He's from UNOSAT. UNITAR is the institution, and he leads the program called UNOSAT. So Einar, please take over. Thank you.
Thank you very much. Yes, from my side, I think it's still early days when you talk about the COVID experience. But of course, there are many things that evolve that we see coming out of this. What we've seen from our side is let's say, the understanding what satellite imagery can do. Anything remote, how useful it is. And of course, in a scenario such as this, I think that aspect is fundamental. So COVID has learned us that we are able to get information over places where you cannot necessarily go. Now, in this, of course, specific scenario, it's the impact is in Europe, but it could be anywhere, of course, this situation. So I think from that aspect, I think there is more understanding and appreciation of what space technologies can do in order to support such efforts, and looking at let's say the damage scenarios. From other points, I would also say that there are, let's say, other institutes that are more specialists in specific topics, and I think those should also be very much consulted. When it comes to earthquakes, hurricanes, earthquakes, tsunamis in particular, there are countries that have been experiencing this. I'm talking about typically Japan, and their experiences in managing this kind of situation and managing also large events. So being able to have those experiences well documented. How do you interact with the population? How do you inform the population? How do you ensure the level of fake news is dealt with? So in a situation such as this that we are discussing, I would assume that it would be a lot of fake news flourishing very fast, because people will have time, and they will have time to, let's say, have all these crazy theories developing. So I do think it's extremely important to have a communication role, and very, very well defined. And of course, authorities will have to be extremely vigilant on how you communicate about this threat for our scenario. But I do believe absolutely that one can rely on other countries and their experiences, because there are many have had such not this type of event, obviously, but again, the pandemic has learned us that you need to really reach out to a lot of people. You have to keep the information very simple in the way you communicate. So I think it's going to be a huge communication effort in order to manage this kind of situation. So technology can only do so and so much, but it's really about how do you inform the general public in an easy to understand way, of course, to avoid panic, and making sure that it is really information based on science and facts that are getting the headlines, let's say. Thank you.
Thank you for giving.
Go ahead, Serge.
Yeah. You want to take or you want to speak now?
Yeah, I just wanted to make sure that everybody knows that we do have the chat room open. So if you have a question or you want to make sure we pay attention to that, make sure you put it in the chat room and just address it to everyone. And as we go through the panel, we'll try to make sure we have enough time to answer as many as possible at the end. Thank you. Go ahead, Serge.
Right. Thank you. So thank you, Einar. You brought this perspective of how space technology helps, and of course, attention to the disasters that the particular countries and region have experienced and how they are well documented, including how to use the technologies very well. We will build on that, and we'll definitely find some questions to discuss. But I think I prepare initially the one turn of all the panelists and then come back for discussions and questions. So I will speak towards end, but let me invite then Catherine Ron, Professor, George Mason University. Catherine, please, floor is yours.
Shrivesh, thank you so much. Hello, everyone. It's a pleasure to be with you. Einar, I think many of your points were very well made, and I think one point that you're making is that the pandemic is a big lesson learned for us about how we deal with high consequence, low probability events. Let me begin with a brief story of a painful experience that I had that taught me some lessons. And I'm very interested in other people's thoughts about this. But back in 2005, we had a very heavy hurricane season in the United States. And so meteorologists were warning us to prepare. And the emergency managers, some of them invited me to come and speak in New Orleans to learn about their preparedness efforts. And one of their efforts was a plan to make sure people in the heavily populated area of New Orleans could evacuate. And so because not everybody can be on the highway at the same time on the roads, people were put in a queue. And so some neighborhoods could evacuate during the daytime, but some people had to evacuate in the middle of the night. And so when I spoke in July of 2005, most of the emergency managers were their time was consumed, and they were worried about how to talk to people who were upset about their place in the queue. I left and I felt good that I'd spent a lot of time talking about how to talk to upset people. And then at the end of August 2005, Hurricane Katrina hit. And those people who were upset, who were thinking about the danger back in July, most of them escaped. They had cars and they were mostly middle-class people. And the people I failed to talk to were the vulnerable people. People can be vulnerable for all sorts of reasons. You know, they can be hospitalized, they can be elderly, they can have lots of animals that they have to take care of and who are difficult to transport or evacuate. But what I realized afterwards is I failed to listen to their logistical challenges. And so what I learned was that I needed to read the disaster sociology literature. And if I had read that, I would learn that effective communication should be essentially, it's kind of back to the point Einar was making, that we always have disasters happening of various sorts. Some are more predictable than others. But what we need to do is use all of these many things, the floods and so forth, as opportunities to learn, to listen to those vulnerable groups. What did I get wrong the last time? And what are the systematic ways of learning their logistical challenges? And I'll stop with this point. I think maybe LA or someone else could pick up on this, but systematic ways of listening. There's a literature called deliberative meetings. It's essentially randomly select people from various groups, listen systematically, let them learn from experts about the danger, and then learn from them what the logistical challenges are, and then summarize the report to appropriate people so that you have a feedback loop. Is one tool in the toolkit. There's quite a bit of literature across the scholarly world on this topic. But let me stop, and I'm wondering if I should pitch it to LA or someone else in disaster management who's had these experiences and knows from who has many experiences to talk about in emergency management. Thank you.
Catherine, thank you very much. Sarusha, I think what we could do, Sarusha, I follow your example. Let's go to give our other panelists an opportunity to speak first, and I can address some of the things Catherine was talking about.
Thank you.
Good. So thank you, Catherine. And then let's go to our next panelist, David Schud, Deputy Director of Preparedness. Okay, I don't have your organization. Can you please introduce yourself a little better, because in the agenda it is introduction mentioned. So over to you, David, please.
Okay. Good morning, everyone. And thank you for letting me join. My name's David Scholl. I'm a Deputy Director of Preparedness for a consulting firm called Haggerty Consulting. But I am serving currently as the coordinating officer for Salt Lake County's response and recovery efforts to COVID-19. So good morning from Utah. A lot of great panelists and conversations to date. And I just wanted to talk about 5 general concepts that I've been experiencing since February 28th, 2020. Just a second. Okay, I'm sorry about that. The 5 comments that I wanted to make were: 1, the necessity for a multi-agency approach, particularly in low likelihood, high impact scenarios. What I have discovered in my experiences here in Salt Lake is a siloed approach to preparedness, where, for example, health departments, emergency management, law enforcement, supporting agencies develop plans, exercise them, but exercise them inclusive of everyone, exclusive of everyone else, where that level of engagement and integration and preparedness is lacking. I've have colleagues across the country where the health department and emergency management agencies did not work well with one another, did not practice pandemic response together. And that was an issue that came up. Second, the pain of cascading effects. And Catherine, talking about New Orleans, highlighted this. COVID and the pandemic here has shown what cascading effects can do, from understanding vulnerable populations, equity and access issues, the far-reaching impact of a disaster, bridging the digital divide being one of them, housing issues, things that emergency managers who are very much response-focused may traditionally not think of. Third, just politics and the pervasiveness of politics. And this gets to Einar's point about fake news and hysteria that we discussed yesterday. A lot of the individuals that would be, and departments that would be working in a low likelihood, high impact emergency may traditionally not know disaster management. They're what I would call civilian agencies. And so there's a high learning threshold for those individual agencies to come on board. Fourth, just a slow burn of disasters. COVID has shown us sort of the torturous fatigue from a response perspective, and thinking through staffing, thinking through just generally in this scenario, what we're talking 4 months of notification. What psychological and effects, operational period effects will take place to those staff members. And then lastly, just the need to exercise. I just want to thank you all for letting me participate in this. And how do we engage in conversations with elected leaders, with departments on low likelihood, high impact scenarios like this one today? That's all. Thank you.
Thank you, David. I think all three panelists have set the tone for discussion. With Einar talking about the space technologies and all related aspects of disasters and all. Then Catherine talked a lot about experience from Hurricane Katrina and then communication. And the very important point was how vulnerable people get affected. Those who have resources, they escape. But the poor get affected, and that is the lesson drawn from international disaster frameworks as well. The important is what we do, how we plow back that lesson. And then, yes, David, you have talked about those five very important points, and the exercise that you try to correlate how the exercise and the experience from low onset disasters, how they can be correlated, and we can learn the lessons. Fantastic.
So we also have one more panelist we should reach out to. We have Laura Manny from the Center for the Study of Existential Risk from the University of Cambridge. Maybe we should get her to join in to give us a few remarks.
Okay, great. Yeah, please. I didn't have that in my list here, so on the web. But yeah, welcome.
Thank you. Hopefully you can hear me okay?
Very well.
Now we hear you fine.
Okay, perfect. Perfect. Yeah, thank you. I was a bit of a last minute addition to the panel, so thank you for accommodating me. And as LA rightly said, I work for the Centre for the Study of Existential Risk at the University of Cambridge. So perhaps I come at this discussion with a slightly different hat on than some of the other panelists. And high impact, low probability events are certainly our bread and butter. So that's not just asteroid impact, it can also be engineered or natural pandemics, as the COVID pandemic, which we're living through, all the way through to the malicious uses of technology, nuclear risk, all these kinds of risks that threaten our continuation of humanity. And that's very much what we talk about when we talk about existential risk. It's the risks that could potentially wipe out humanity, or one step just before that, global catastrophic risk, which is the severe curtailment of humanity's potential. So a loss of around 10% of humanity's population, or leading to the collapse of civilizations. So I note that even in the worst case scenario of the modeling of 2021 PDC, that at a 6.6 million population affected, it still falls short of the global catastrophic risk. Nonetheless, we don't have the ability to learn from existential global catastrophic risks, to learn the lessons. And so it is really important for us to learn from things like COVID. And of course, Ina pointed out that we're really just trying to unpick COVID now as it is. But there are some things that I think we can draw and are particularly applicable to the planetary defense community. And I work in thinking about how we can communicate these complexities and getting people to take action towards mitigation and prevention. And so one of these methods is, of course, scenario-based exercises, as you're running here as part of the Green Zone exercise in PDC 2021. But I'll have a word of caution here, because of course this community is not the only people that are using scenarios. In the biosecurity community are heavy users of scenario-based exercises, and you would have heard of Event 205 or CLADE X that were run by Johns Hopkins University, the Event 205 just at the end of 2019. Also in the UK, we ran Operation Cygnus in 2016, which was, they're all about simulating the spread of either Event 205 was a novel coronavirus, and Operation Cygnus was a pandemic influenza. And they all came with lessons, just as very much recommendations and lessons that as we are drawing from this exact scenario-based exercises. But yet we were still unprepared. Many governments failed to take action on many of the recommendations that came from these scenario-based exercises. For example, the UK government, that's very much my perspective as that's where I'm based, failed to take action to make sure that we had PPE supplies, or to make sure that we had ventilators, and when they were modeling a respiratory virus. And one of the reasons for this is because there's a lack of incentive, and there's a lack of accountability when they fail to do this. So one of the things that we think is really important here is incentivizing our governments to take action. Of course, no government wants to run a mandate that's based on high impact, low poverty events, when Mrs. Jones down the road's garden floods every year, and she wants her river to be protected and maintained and managed. So it's really about making sure that our governments are correctly incentivized to take these things seriously, but in a way that it doesn't take away from the fundamental day-to-day issues. So one of the problems with this, of course, is short terms of office and a lack of long-term thinking in our governments. We can't rely on the changes of administrations and their kind of approach to taking on these risks seriously. Of course, the climate crisis is a fundamental sufferer for this and the change of administration in the US. One way that we think is a way forward is to having positions outside of governmental terms of office. So within our governmental institutions, but also in fundamental organizations that deal with risk. And this kind of chief risk officer position that can have a long-term view on such slow burn risks is highly important. And the point of that is to make sure that we can sustain the thinking and the approach to the work that we do, but also the funding and the finance that's required to make sure that we're working towards mitigation and prevention. On the public angle, which is obviously a massive kind of point of learning from the pandemic, and I really want to make sure that we talk about publics as plurals rather than the public, because there are many different publics, many different viewpoints, many different cultural experiences. And one of the greatest lessons that we've learned from this, and is of particular value to the planetary defense community, is the strong compliance that publics have shown towards mitigation measures, the draconian kind of lockdown measures, and health protection measures too. And for a long sustained period of time, we're seeing that lockdown measures are still working well, and people are still wearing face masks. I actually live in France, compliance with wearing face masks is incredibly high, despite the longevity and the uncertainty associated with the pandemic. Of course, fatigue is beginning to set in, and I'm sure I'm as fatigued as the rest of us. And so really thinking about how we can sustain that. Imagine if we had identified PDC 2021 in that 7-year period prior how do we maintain that compliance and that resilience within our publics and communities. So I guess I'll leave it there, but
Laura, that was great. Thank you very much. I was actually quite impressed with some of the things you brought up, and Teresa, I didn't want to interfere with your questions, what's going on, but I do want to mention, let's start off with the idea that, well, I want to make sure I'm understanding you. Are you saying, Larry, that the exercises we're doing are too specific, or the scale is not big enough? I would say that as a disaster manager, there's a certain limit of how far I can go with exercising something. So if I go to someone, say we were doing the most extreme example of PDC 21, and we're talking about 6.6 million people, that is a scale that I don't think anybody has actually imagined before of doing it, and especially with the complications that would exist in Europe, where I have 50 states, but having multiple nationalities have to respond to this would be an issue. And I'm also fascinated by the idea of a chief risk officer. However, I don't know of any national system other than doing it within your government that can consistently work on a threat basis or a risk basis. You're always going to have a change of administration, at least in a lot of democratic countries, where you're always going to deal with that change. So I'd be interested in pressing you on, so what would you say? Exercises are not big enough, we should think more broadly. I just want to make sure I follow you on that.
yeah, certainly. So that's a really good point. And I'm not saying anything against the scenario-based exercise. I'm thrilled to see the planetary defense community working towards scenario-based exercises. It's been brilliant to follow. It's been excellent to see the cross disciplines, the interdisciplinarity. But it can only be the first step. And of course, the planetary defense community can only be responsible for a certain amount of the response and the prevention and mitigation of such risks. There is an aspect of political will and social, the kind of institutional resilience that needs to be incorporated too. So although it's brilliant that you're bringing together, and that is, of course, the main kind of strength of the Planetary Defense Conference and doing this scenario-based exercise, but the next step is to involve decision makers in these scenarios, which is certainly how Johns Hopkins have approached some of their scenarios around the event 205, which had quite senior level political actors, as well as there's Operation, I think it's Dark Winter, where they also did something similar, and they had very high level kind of stakeholders. And that's certainly something that I think perhaps we can evolve these scenarios further. What we should also say is something that's very important is adopting other methods of foresight and horizon scanning and understanding what is coming for us. I mean, I think that sounds very dramatic. What is the risk that is posed to us? How can we quantify it, and how can we make sure that our systems and mechanisms for response and recovery are ready? It's how do we get our disaster managers to think of all of the aspects? The only way is through modeling, through scenario exercises and expert elicitations. It's having the people with the knowledge in a room having these discussions, which is exactly the purpose of this conference. On the Chief Risk Officer, this is something that we have proposed to the UK government. They're currently running an inquiry through the House of Lords on the way in which the UK government think about risk and risk management strategies. And this has been brought around by the pandemic, absolutely by the pandemic, and the fact that pandemic influenza was the #1 risk on the UK risk register and has been since its inauguration back in 2012. But yet we were still unprepared, and very much we see that as a failure of implementation. It's actually a failure of actually taking the things that we do know how to mitigate and prevent and actually putting them into practice and action. And that's very much where we have to bring in decision makers and stakeholders at a very early stage to make sure that those measures and those recommendations that we have are being actioned.
Okay, thank you very much. I appreciate that clarification. We had a couple of comments also from my colleague, Dr. Linda Billings, about their different publics. Another question I had for David, I like the 5 points you brought up, David, and from a practical aspect, stovepipe exercises. Based on what we've been doing for this week on a PDC. Do you think that we've done a little bit better job with regard to the stovepipe? I understand preparedness guys do one thing, readiness guys do something else, operational guys do another thing. And I have been in a practical exercise where the public health, most people will assume that the public health guys and the emergency guys are the same group of people. They are not. And oftentimes they don't talk to one another. So David, if you could answer that question about how do you think the PDC was with regard to that, and how you would approach it if you were a local official in Utah where you are now and you heard about this.
Yeah, so I mean the fascinating silver linings of COVID is that we are understanding a need to reorient ourselves in preparedness and making sure that we are comprehensive in our approach to sorry, I'm dealing with a situation here in Salt Lake. So working through which partners, creating a more unified approach to preparedness. So instead of public health having their own emergency management, instead of emergency management having their own emergency management, instead of law enforcement having their own emergency management, trying to understand how we can come together and really think through a more integrated approach. And that is one thing that we're learning, and it was challenging the first time around, but we're getting a lot better at it, and I think that's where we're heading, and part of that is looking at, is there a point of exhaustion with the pandemic? Definitely. And there's a need to look at other scenarios and plan for it. Here in Utah, we're talking about earthquakes again, which actually is one of the most relieving conversations to have, to talk about a catastrophic earthquake instead of a pandemic. So yeah, there's lots to be learned from COVID.
Okay, thank you.
Yele, can I take my turn? I have certain lessons to share, and then you can go back for questions.
Yes.
Maybe you can. Okay, good. Just a few minutes. What I want to share is in 2020, we, as a UN Spider program, we organized a conference. Of course, our focus is on space technologies, as does INR have. But our theme was more on lessons learned from COVID-19 pandemic, and then we got a really good disaster managers from different countries, and they shared their experiences. Although the focus was a little Asia Pacific, and our scenario here is more on Europe, but I think it's always good to learn from different regions. So some of the lessons learned I just documented. So one was that the magnitude of such crisis that pandemic has, it goes beyond just humanitarian issues. It awakens the notion of building resilient society through resilient development. So that is one of the, I mean, we have seen that how these oxygen supplies and the vaccine development of vaccination and distribution, everything collapses. So that was one of the observations that was there. Then disaster management community is uniquely positioned to contribute to such kind of challenges because they have these disaster management rules, laws, standing orders, and all kind of things. So they can contribute into such kind of when such kind of big disasters happen. But what we need is information at various scale to capture systemic risk. And when you have the systemic risk information about systemic risk, one can do predictive analysis for providing prescriptive measures, basically for decision-making process. So simply the maps that showed where the pandemic is more, where are the nucleus of pandemic, where people are more affected, and the other disasters coming in that area, if those kind of cross sections people know, then a lot of prescriptive analysis can be done, and then people can be prepared well in advance. And that was done in some of the countries basically. And one of the example is cyclone Amphan in India. They spoke about how this record break torrential rain basically were brought by Amphan plus pandemic. And another example was also from Japan on the rains on island of Kyushu, how it triggered the floods and landslides. And there were contrasting requirements. On one side, evacuation of people, and on the other side, social distancing due to COVID-19. And this was the first experience for disaster responders in those kind of that were 2020 basically. So they needed more shelters and more precise information on how many people to be evacuated and all that. So these are some of the therefore importance of systemic risk and predictive analysis was very well highlighted. They also talked about power of space technology, big data analytics models, which are very important for building and implementing such scenario-based approaches. So use of those technologies definitely, and space becomes very important technology for addressing systemic risks because most of such risks are transboundary, stochastic, non-linear, and uncertain. For example, this particular near-Earth object threat, it's also transboundary and quite uncertain. I was speaking in one of the webinar a couple of months back, and when I mentioned something about planetary defense conference and NEO threats, one of the NGO person says, do we really have to think of those kind of futuristic, because we have so many other disasters and pandemic and problems to deal with. And I think in the comment also someone has posted that particular that someone says that, oh, let's better deal with pandemic than thinking of near Earth object threat. But yes, looking at pandemic, it came after 100 years. So something in 1918 and now 2020. So after 100 years, and we forgot. And most of the disasters, when they happen, we forget. Even earthquake, I have seen in some countries, in my region itself, in India, I'm from India, earthquake came, some 50,000 people died in 1993, and then people have forgotten about earthquake. Everyone knows that earthquake will not repeat in that area for next 100 years. And that's how we forget the lesson to be drawn. So anyway, the conference finally basically highlighted all those important lessons learned. And of course, when I'm talking about the uncommon disasters, even knowing some possibilities, how like many cities are sinking. So for example, Bangkok is sinking, and in 2011 more rainfall happened, and 4 months that part of Bangkok was underwater, and more billions of dollars were lost. This is not visualized as a disaster because city is sinking maybe some 100 millimeters a year or something like that. But there is a technology, INSAR satellite technology, they can measure precisely at what rate cities are sinking. There are many cities in the world they are sinking, and they will invite a lot of disaster. And so technology can be used. So what I'm trying to say here is the conference brought out several lessons learned from COVID-19 and other disasters, which are applicable for basically for NEO threat also. And this kind of simulation need to be planned because we have seen the Spanish flu pandemic, we forgot, we never did any simulation exercise. And in 2020, we have so many technologies compared to what we had in 1920s. We didn't have any technology. Now we have all the technologies, but humanity is still struggling probably much worse than that time. So technologies and other things are still not helping. So this is what probably is important, that futuristic approach and having some scenario building and practicing that is important for these kind of disasters. That's what was my opinion. Anyway, that was just my turn to speak few things. So Yele, back to you.
Thank you, Suresh. Einar, do you have any other comments? Your comments were kind of short before. I want to give you an opportunity to add on to your comments before we get to any more questions, if you like.
Yeah, thank you. No, I just want to also raise something that we discussed a little bit yesterday. I think you've touched upon it a little bit today as well, and that's the issue of training and capacity development.
Aina, your transmission froze. Aina, do you want to try to come back?
The issue of an asteroid, but it's also an issue of a meteorite, but it's also an issue of being prepared as having different scenarios for different types of hazards. So I think having that more as a general attitude among governments is something that we will see as a huge benefit. So I think yes, the issue of capacity development and training is going to be extremely important. And the nice thing here, I think, is that you can do it across the board. So you can do it from the you know that there will be the hurricane season is coming up, so every year they will have that. But you can have that and going all the way to these very kind of unlikely but potentially devastating situations that we are discussing. So I think it's as a disaster management community, I hope that the whole COVID situation has woken up a bit. These things can happen, and it's not just what you are forecasting seasonally, but it's something that is bound to happen sooner or later. And why not have a plan for it? So I think it's all these things that we need to come together, and we need to get governments on board and have scenarios plans. Because of course, as we see in the whole COVID situation now, one of the biggest criticisms to government is why we're not prepared. Why didn't you get your oxygen stocks? Why did you have it in advance? Why didn't you have all the masks, etc.? That's easy to say after. And I guess the same thing would be, if there should be a situation like this, it would be, why didn't you plan for this? Yes, it's unlikely, but it can happen. So I think, that issue of training and capacity development is extremely important.
Okay, thank you very much, Einar. Catherine, I can maybe go to you on this question. We in planetary defense, we have that unique science difference where we can have no warning hours, weeks, days, months, or years. Well, based on our experience, to me, as an American, if we say we have an impactor that's 6 months out, I think people will be concerned, but they'll also be concerned about the wildfire that's in the next county over from me. I'm still responding to COVID, but in the back of their minds, we're very optimistic. They're going to assume that somewhere somebody has a plan for this and it's all figured out. And where people get mad is that it doesn't work out. So in your experience, like I know a lot of people still talk about Katrina, but I like to also emphasize that we learned a lot of hard lessons after Katrina. It wasn't that we forgot it, and a lot of times we often do forget the lessons learned, as Sharice was just pointing out. But for Katrina, we did learn a lot of lessons. A lot of it was, what about people that don't have cars? One exercise I was in, who goes around and picks up homeless citizens that don't have a place to stay? How do you take care of them? How do you evacuate them? So there are some additional things. So Catherine, if you could expand on the communications differences where everybody's already tired of the pandemic, and this is something that am I correct in assuming that people think that this already a plan out for this?
LA, I think your points are so well taken. So this is really hard because I think the biologists and the neurologists have told us our brains just don't do very well with long-term risk. I'm sure Laura can talk more about that, but we're designed to think about the risk that's right in front of our faces. So we really have to use our advanced brains to care about those apparently long-term hazards, even if long-term equals, a couple of weeks or a couple of months, they seem remote to us, and the fact that I don't have my taxes done and they're due May 15 is a good example. We're all like that. So I think one strategy that I've learned from actually the ready.gov site under the community emergency response team windows, and I can put that in chat if that's helpful, but basically what they do around the United States is they put the spotlight on a community that's working hard to address some long-term danger, some that approach the existential dangers Laura's been talking about. So things like wildfires in the West or whatever that could destroy a Western U.S. town. And then they showcase the strategies that group is using. So one group in Fort Collins, Colorado, is using an old European technique of having goats come in and eat the dry brush around apartment buildings and homes, as opposed to lawnmowers, which reduces their wildfire risk. I guess the point I want to make is they showcase this town that's working on this existential risk and showcase what they're doing. And my belief would be if we could share those stories across the world, perhaps, of people, communities doing a good job of figuring out what's dangerous in their community and then finding ways to address it, that would help. And the link to, low likelihood risks like an asteroid, I think is the national government in various countries coming in and helping people see that the preparedness that you do for the wildfire or the flood in many ways is the same as the preparedness you do for the asteroid strike. The emergency management community knows that, and you essentially keep teaching us that essentially we need to either have enough supplies at home or know how to evacuate with enough supplies and be findable. So I think it comes back to how do we avoid exhausting the emergency management officials, and how do we help communities to take ownership of a range of dangers, some of which are long-term and some of which are short-term. None of this is easy. I'll just make one more point, harking back to something Laura said about a risk officer at the national level. I know Spain and the United Kingdom do a really good job of having standing groups give the national legislature advice on science and emergency management and public health. We used to have that in the United States and we got rid of it in the 90s. But having some sort of standing group look at long-term risk is across the types of risk is one helpful tool for helping us prepare for all these dangers. So let me just end with one point. I think our best approach is the whole community, all hazards preparedness approach. That's easy to say aspirationally, but it's very hard to pull off because it exhausts the emergency managers. And I'm not an emergency manager, so I don't know what we can do to reduce that exhaustion problem among your expertise, your group, except to take more ownership of it in each of our communities.
Okay, thank you, Catherine. We got about 9 minutes left. David, I saw you nodding your head to some of the comments. Catherine, you wanna jump in for a second?
Yeah, I mean, just as a practitioner of emergency management, prior to COVID, I worked on acute, low likelihood, high impact for a local community. That being complex coordinated attacks and counterterrorism here in the United States. What a Mumbai or Paris or Brussels looks like, and a year, and I mean, it's been over a year of COVID response for me. I think one thing that I've learned is emergency managers, public safety, find comfort in terminology. The incident command system here in the United States is tried and true, it works. But when we try to build out and as part of capacity building, develop a cadre of individuals to support a response or preparedness, the terminology that we've been using, the hyper specificity of it must be like this, it becomes a challenge, and we impede our own progress there. And that's the same for an asteroid impact. How do we get conversations going where we can, take the issues that we need to address in near Earth orbit impacts and localize it, where it's something that is comprehensible to the local county emergency manager or even the mayor. When talking every day, I have to talk about doubling rates, case rate increase, vaccination outputs, thresholds, and how could we make that how we talk about emergency management, disaster response more digestible to who we're working with.
Oh, that's a great compliment there, David. Thank you very much. Back to to the panel in general. While we got let's see, we got 6 minutes left. Anybody want to grab this for the asteroid impact scenario? Based on what could possibly happen, a lot of the changes where we have to evacuate people or shut things down. The idea of thinking long term that it's going to be permanent. Have anybody given any ideas to, like, if the impact is going to be your town, and by the time it's over, your town won't be there? The consequences of trying to get the governments and other organizations to discuss the fact that this is now a permanent change to how we're going to do things. For instance, us doing this conference virtually, we've got really high cooperation, participation, but we know in the future that virtual is here to stay. The next things are probably going to be hybrid. So anybody got any remarks on how we communicate the idea that this is probably a low occurrence, but extremely high consequence, and after the consequences, what happens afterwards might be a permanent fixture. So we have a very difficult, and I think that's a hard thing to convey. I don't really have an idea of how we can get that across to people. Anybody?
I'd love to come in there, and I don't have a solution to that, of course, and I doubt many of us do. But this is certainly something that we are currently seeing. So one of the areas that I have worked quite a lot on over my career is St. Vincent in the Caribbean, which, as you all probably know from the media, is undergoing a massive explosive volcanic eruption. And many of the houses and buildings within the red zone, the very high risk zone on this volcano, have been destroyed, and there certainly aren't places for people to go back to. And there are people in emergency shelters. We're talking over 16,000 people that have been successfully evacuated within time. And this is definitely a very strong lesson learned here. The success of this this crisis, but it's something we're actively trying to deal with and trying to think about how we can communicate this to publics. One of the ways we are currently doing, and this links really nicely to the session that we've just had on communication and the messages from Leah on narratives and stories, is by using other communities. So we're trying to connect people on the island of Montserrat to tell their stories to people living on St. Vincent, who are now living with incredible amounts of ash and the fact that they no longer have homes, and thinking about what that resettlement looks like. And there's some islanders that experienced the last eruption in 1979, and we've worked really hard over the last 5 to 6 years. A massive team of us, I'm talking about myself, but there's many people, and that's the key, is this is always a team effort, have worked really hard to make sure those stories and those cultural histories that we've heard talked about here are embedded into our societies, and that's very much around that. But we must also think about individual resilience too, and we can't just always talk about financial resilience or societal or political. It also has to be at the individual level, and certainly things around that must be about dealing with mental health issues in crisis situations and understanding how to empower those communities. So I don't have an answer, but that's a really prescient example that I think we will learn a lot of lessons from.
Catherine, go ahead. See your hands up. You're muted.
Thank you. Just Laura, briefly, I think your point is so well taken. Finding a community that's gone through similar horrible events and having that social support of learning with them, that's very similar to what we do with support groups for people with diseases. So, you come down with some rare disease and you feel very alone. One thing that is very helpful is meeting other people who have that rare disease and learning what helped them. It gives them hope. And I think that I'm really intrigued by your example. Thank you.
Sharice, go ahead. We got 2 minutes.
Yeah. So that's why I'm not talking on your point. That has been sufficiently reflected, but I just want to leave this particular session with very positive note on behalf of the developing countries as well. Couple of years, I say 10 years back or 15 years back, most of the developing countries, they did not even have a national disaster management authority or disaster management agency or ministries dedicated for disaster management. Today, with awareness created by UN Office for Disaster Risk Reduction, Hyogo framework, and Sendai framework, most of the countries now have got disaster management organization, very structured way of getting all the stakeholders on board, including health ministries, science and technology, and all that. Sustainable development goals have recognized value of science and technology, and there are very high level political forums on science and technology and innovation for building resilience and many things. And there are committees in each country where all ministers basically sit and they basically drive the disaster management. So this has started, and most recently I will tell you, the most recent country is in Nepal. About 6 months back, they started National Disaster Risk Reduction and Management Authority in 2020. So you can imagine the countries are coming on board, they are getting systematic, and this is a very positive note, because if now we talk of threats like this NEO threat, the message will go across in one stroke to all the countries, and the knowledge will be retained, and they know that such a threat exists, such a information sources are available. There is IWAN, there is a community on this particular PDC community that can help. And I think if we can just take care of addressing those things through such international platform, I think we are very well placed. The only important thing is not to forget the lessons learned and keep practicing it. I think I just wanted to leave at that point. Thank you.
Okay, everybody, thank you very much. Brent, I think we're at the end of our time. This has been a very lively discussion. There's a bunch of lessons learned that we still have to go through. And hopefully we won't have to do this for real, but I think from what our scientist colleagues share with us, this is going to happen sooner or later. It's best to be prepared. It's probably going to be one of the most complicated situations I think the international community is ever going to have to take up. So thank you very much, Brent. Over to you.
Thank you, LA, and so many thanks. And so we will go ahead and proceed with our next session, doing another excellent job of sticking to our agenda. So without further ado, I'm going to turn it over to Michael Aftosmus, who's going to lead us in our impact effects section. Michael?
Thanks so much, Brent. Yes, so I'm Michael Aftosmus with NASA's ATAP project at NASA Ames. And on behalf of my colleagues, Mark Boslow, Jesse Dodson, Dave Morrison, and Olga Popova, I want to welcome everybody to the second now impact effects session of the day. In this session, we're going to pick up our discussion of the direct physical consequences of asteroid impact. These include blast, thermal, tsunami, as well as environmental and potential global effects. Before we begin, I want to remind everyone, I have a list of the speakers here in the session, but I want to remind everyone to make time to take a look at the e-lightning talks and posters. The links for those are at the bottom of the full program, down near the last page. For speakers, we're going to hold you to 8 minutes, and I'll give you a warning at either 1 or 2 minutes when we're getting close, depending on how it looks like things are going. With that, I guess we'll go ahead and start first.
Thanks, Mike. Can everyone hear me?
Yes.
Jesus. Okay, cool. All right, yeah, so I'm going to talk about some recent results using the SPH code Spheral to model the entry of an asteroid into Earth's atmosphere. We primarily focused on the smaller end of the spectrum for the PDC type body. Next slide. We can actually skip 5 slides forward. Yeah, so airburst events are primarily driven by smaller asteroids, and I was probably a little generous here with 100 meters, but they're on the smaller end of the spectrum, and these bodies are 1, higher frequency, and 2, harder to detect. So it's a very different type of scenario versus some type of larger body that might have global consequences. And the ground effects are probably going to be driven by the yield and the height of burst, and to a lesser extent, the geometry of the burst as well. And the yield can be easily calculated from the mass and the velocity of the body. But things like the height of burst and the geometry of the burst are going to be dependent on how the body breaks up in the atmosphere. And so these are naturally going to be of interest for consequence assessment. Next slide. So we chose to use smooth particle hydrodynamics to model the breakup process. And it's an interesting tool for this type of problem because it naturally handles large deformations, and interface tracking is natural as well since it's Lagrangian. It also has good conservation properties. And I think just having another modeling technique to do this is good. So it's a good complement to grid code results. Next slide. So yeah, now I'm going to give you all the caveats of what we didn't model. So this was only 2D planar. We used Euler equations, so there's no radiation, there's no heat transfer, there's 0 strength, so we're at the fluid limit here. And we were also using the gamma gas law, so there's no high temperature effects in these results. Next slide. So the breakup process is largely driven by hydrodynamic instabilities. And so you get Raleigh-Taylor instabilities being set up because you have this denser body supported by the lighter air, and you have this kind of effective gravitational acceleration due to the deceleration of the body. But you also have Kelvin-Helmholtz instabilities due to the shear layer. So you end up having this generalized Raleigh-Taylor instability. Next slide. And so these types of instabilities typically begin in an exponential growth phase that's well predicted by linear theory. And they end up in this self-similar mixing turbulent domain. And where our peak energy deposit kind of lies in this growth trajectory is going to inform how predictable the energy deposit is given a set of conditions. Next slide. So we wanted to look at the sensitivity of the energy deposit to small perturbations in the initial conditions. And so in order to do this with our particle code, we just rotated the particle distribution for the asteroid. And so here we have 6 different cases, and each one's rotated by half a radian. And on the right, you can see the results. And you can see that there's some pretty big variations in some of these sharper peaks, but most of them agree fairly well that the energy deposit begins around 14 kilometers. However, there is an outlier here in this set of 6 that begins increasing around 12. So even with these small perturbations, you see there can be some pretty significant variation. And sensitive depends on initial conditions seems to be a somewhat important factor in these simulations. Next slide, please. Oops, sorry, next slide, please. Oh, thanks. Oh, sorry. Go back one. There we go. Okay, yeah, they're perfect. Thank you. Yeah, so I wanted to look at where these perturbations kind of were visually in comparison to our energy deposit curve. So up top, we have some log scale density plots. So you can get the shock and you can get the solid and black. And then I drew just red lines to indicate where these different images fell on the energy deposit curve versus time. And so our image in the middle here at 1.75 seconds is basically the start of the energy deposit. And this is where we have these Rayleigh-Taylor spikes kind of shooting off. And the peak deposit really occurs when we have full breakup and we're kind of in this turbulent mixing phase. So this kind of aligns with the sensitive depends on initial conditions we were seeing in the previous slide. Next slide, please. So we then wanted to see if we could see these perturbations by perturbing the surface with some sinusoidal function. And so we examined 3 cases, one being just around a perfect circle, and then 2 different frequencies of 16 and 32. And for each case, we ran 6 of those perturbed rotated cases. And here on the right, we have the averages. And interesting, you can see that when you perturb the surface, it appears to flatten the curve and actually shift the deposit to lower altitudes. Next slide, please. But if we overlay the ensemble, you can see that the sensitive dependence on initial conditions actually created a larger spread than the perturbations to the surface. So it seems as if the sensitive dependence on initial conditions might actually be a more significant factor here. And whether or not this is a significant result due to the perturbed surface is somewhat questionable. Next slide, please. Here I just have the energy deposit rate. So the last one was the energy versus altitude. And so this is just again showing that the sinusoidal surface perturbations seem to cause the body to break up at a lower altitude. Next slide, please. Yeah, so this brings us to the conclusions, and yeah, so the major conclusion, or I guess the most significant one out of this, is just that it appears sensitive dependence on initial conditions was a pretty significant factor for this dynamical system. Though I do want to note, this has been examined in the past with grid codes by Korakonsky and some co-authors, and they found that in 3D, the sensitive dependence on initial conditions actually seem to be reduced somewhat. So this might be more a matter of the 2D nature of the simulations. And then the second conclusion I just phrased as a question because it's not really certain from these results whether this is a significant result. So the results suggest that it's possible that surface perturbations might flatten the deposit curve a little bit. So with that, I'll finish up, and thank you for your attention.
Thanks so much, Jason. If you've got questions for Jason, and since this is the only SPH talk in the session, please go ahead and put them in the chat, and we'll capture them for later on. Our second speaker is Marcia Berger. Marcia's a professor at NYU's Courant Institute, and she's also a member of NASA's ATAP team. And Marcia's going to look at developments in tsunami modeling for water impacting events. Marcia, go ahead.
Thank you. I'd like to acknowledge my collaborator, Randy Levesque, and also the support of the Asteroid Threat Assessment Project at NASA Ames. Next slide, please. The goal of this work is to develop a high-fidelity model to simulate impact-generated tsunamis. So what's different about asteroid impacts than earthquake-generated tsunamis? So the main problem is that impact tsunamis have much shorter wavelengths. So the usual shallow water equations typically used in earthquake-generated tsunamis are not a good model. Earthquake tsunamis have wavelengths on the order of hundreds of kilometers. Impact tsunamis can have wavelengths on the order of 10 kilometers. Now, for ocean scale propagation, however, we still want to use depth averaged equations so we don't have to compute the vertical velocity, and that reduces the simulation from 3 to 2 spatial dimensions. Models that include dispersion on top of shallow water are known as Boussinesque, and the problem or difficulty with these is they need an elliptic solve at each time step. In this work, we're using what's called the Madsen and Schaefer model. There's a number of others. Now, even with depth averaging, we still need adaptive mesh refinement because in the deep ocean, You only need resolution on the order of kilometers to track the waves, but for coastal inundation, which is the ultimate goal, we want resolution on the order of meters. So that's a factor of over 100 in refining the computational mesh. So our strategy is going to be to use the Boussinesq model in the deep ocean and switch to shallow water near the coast. There's a little cartoon illustrating that in the bottom right. Next slide, please. This work extends the GeoClaw software, which has been well validated for earthquake-generated tsunamis. It handles moving interfaces, multiple topographical data sets, many other nice features, and most important, it already includes adaptive mesh refinement. It's also been extended to all these other applications listed on the bottom of the slide, and actually a number of them could also benefit from a dispersive capability that we're adding to GeoClaw. Next slide, please. Just to show you one example of GeoClaw, this is a simulation of the 2011 Tohoku tsunami, and it's being compared with DART buoy data from NOAA. DART is not the double asteroid redirect mission in this talk. DART is the Deep Ocean Assessment and Reporting of Tsunamis, and we're comparing their gauges to our numerical gauges. Next slide, please. Just to show you, a little bit further along, this is very good agreement for tsunamis. The actual 10th anniversary of the Tohoku event was actually last month. Okay, next slide, please. For the test cases presented here, we're going to use initial conditions of a static crater. This is a test case found in the literature. The depth is 1 kilometer and the radius is 1,500 meters. Now, of course, we don't expect a depth average set of equations to handle this initially, since there'll be strong vertical velocities that aren't captured by depth averaging. So initial conditions were provided to us by Daryl Robertson, also of NASA Ames, also in the ATAP project. And he ran the ALE 3D code in the 2D axisymmetric mode and extracted the surface for us. Next slide. So this is what the surface looks like approximately 4 minutes after impact. We could then place this anywhere to start our simulation. So in the next results that I'm going to show you, we're putting this initial conditions about 150 kilometers off the Washington coast. Next slide, please. So the goal of this simulation is to see what happens at Grays Harbor, shown here, taken from Google Maps. Now, there are 2 peninsulas at the entrance to the harbor. They're only a few kilometers wide, a few meters deep. Now, this area has been well studied due to its proximity to the Cascadia subduction zone and has suffered a number of serious earthquakes from that event. And good bathymetry is therefore available in this region. Bathymetry is just topography under the ocean. Now, Westport, which is on the bottom peninsula, is also the site of the first vertical evacuation structure in the United States, since evacuation from the peninsula is so difficult. Next slide, please. So here we see the radially symmetric initial conditions and 5 levels of mesh refinement indicated by the black rectangles, one nested inside the other, each one a finer grid. You can see the topography is also refined when the mesh is, and otherwise it's very coarse. For example, the green blob up on top, that's Vancouver Island. So you can't tell from a distance until the mesh is also refined up there. Now, can you do the next 3 slides slowly so we can see the mesh advance, please? Okay. Yeah, and one more. Okay, so you see the grids are following, okay, stop. The grids are following the waves, as they're heading to shore. And now a finer 6th level box has appeared so in time for the wave as it approaches the coastline. You notice the dispersive patterns. So that's the dispersion behind the leading wave as it approaches shore. Now, we are not tracking the waves that go out to the ocean because we don't really care what happens anymore out there. So you see there's a little bit of noise when the grids are removed. Next slide. Okay, if 2 more. Yeah. And now we see what's called soliton fission as the waves approach the shore. There's a combination of nonlinearity and dispersion, and that's a little point of validation because you only see this in dispersive models. Next slide. Keep going. This is a movie because, you know, by hand, since I didn't think it would appear that well over Zoom. On WebEx. Okay, now we're going to watch inundation of the shoreline. We see, again, we're going to look at the solution across a transect of Westport, and the solution will be plotted on the bottom. Okay, next few slides slowly. And we see the wave approaching. It's about 10 meters high, and it totally inundates the shoreline. Yeah, so keep going. Next slide. Okay, so just one step. Do I have like a minute left?
Less.
Okay, next slide. Next slide. Yeah, so this is just a schematic of how you do the mesh refinement. We save the solution to the elliptic terms and update them along with the GO cells when you take the multiple time steps on the fine grids. And then next slide is my conclusions. So we've demonstrated proof of concept that we can use Boussinesque and shallow water combined with adaptive mesh refinement. Now, the next question is, how much difference does it make for shoreline inundation? So earlier, 1D parameter studies, 1D radial parameter studies showed there could be significant differences, like between a factor of 2 and 3, depending on various parameters. And so there's other things to look at. How much does it depend on the switching criteria? We currently switch at 10 meters depth, and we'd like to compare with some other Boussinesque models. Sarah Green-Najdi is a common one these days, and I'll stop there. Thank you. Thank you.
Thanks so much, Marcia. Again, questions for Marcia, go ahead and put them in the chat and we'll capture them for later. Our next speaker is Timothy Titus, who's with USGS in California, also works with the ATAP team at NASA Ames. And he's going to take a look at downstream and downwind effects. And again, this is joint work with NASA. So Timothy, go ahead.
Sorry about that. Unmute button. So yes, I'd like to call out my co-authors, Daryl Robertson with Ames Research Center, as well as Joel Sankey and Larry Manston, also with the USGS. So next slide, please. So over the last few days, we've heard a lot about the initial effects from impact, airburst, thermal radiation, and in the last talk, tsunamis. But what then? What about other effects that are a result of the initial effects? So, and are those sufficiently displaced in distance or in time that we need to worry about them? And so we group these events into 2 different categories. There's the downwind events, debris generated in the air. How far does that get blown downwind? Does that affect the air we breathe? Is that a hazard? As well as the debris that's left on the ground. Is that washed into the streams and rivers? And how does that affect the watersheds and potentially our next slide, please. So on the left here, we have a picture of watersheds throughout the continental United States. And so you can see that an impact in one area can actually have a fairly large effects on a region. And keep in mind that these watersheds are actually, in some cases, interconnected, so perhaps a much larger area. In the upper right, we have a prevailing wind map with crops overlaid on top of that. And so since we know that this particular event is impacting in October in Central Europe, we can see that the prevailing winds may actually be blowing plumes over wheat areas where winter wheat might be being planted during this time of year. Also, this exercise, I think, is ideal for looking at these events as these impacts are large enough where these effects might become important, but yet not overwhelmed by global climate effects. So next slide, please. So how do we characterize these second order, third order events for a rare event? Well, the answer is to start with more common hazards. So for downwind, we're going to look at software that was developed for volcanic eruptions. For downstream, we're going to look at wildfires. And for those of you who live in wildfire-prone areas, you know that fires are preceded by landslides and flood seasons. So we'll take a look at that. Next slide, please. So for this particular scenario, we picked the San Juan Mountains for an impact area. This is a low population area in southwestern Colorado, but it is the headwaters of the Colorado River, which provides water and electricity to over 22 million people throughout the southwestern United States. It is also upwind for agricultural and transportation hubs and corridors, and so there is a potential for impact. We're going to primarily focus on the effects from a 120-meter impactor, but also a 600-meter impactor. Next slide, please. So for downwind estimates, we use the USGS ASH3D model. The volcano observatories use this to estimate and predict ash fallout from their plumes. You have to have wind patterns, and so you pick a date and it gives you a prediction. We're assuming that the mass of the impactor is deposited at about 40 kilometers on AGL. So I'm showing two cases here, both for October 22 using from 1967. So probably the same approximate wind patterns that we would see for this event. We focused on the 120-meter impactor and the 600-meter impactor. So in the upper right, we see the 120 impactor, a bunch of contours. The faintest contour is for 10 micron deposition, and to highlight that area, I've shown that in a red box. So you can see that dust deposition is a possible issue within minutes to hours after the impact for southern Colorado. In the lower left, we see the 600-meter impactor, a much larger area. I apologize, my red rectangle seems to have slipped to the south. However, the contours show that the dust reaches all the way to Lincoln, Nebraska. And so instead of half a state, we're impacting 3 states. Keep in mind that this region is fairly rural, and so air quality, not just for humans, but also for livestock. And once again, this is an area where winter wheat might be in the process of being planted during this time of year. Next slide, please. For downstream, we use the wildfires post-fire sediment predictions from Sankey et al. 2017. This is based on the fact that wildfires remove ground coverage, allowing rains to erode the soil and leads to enhanced sediment into the streams and rivers. There's a variety of ranges in these sediment yields that are estimated for the watersheds within the San Juan Mountains. We're going to use the highest value of 60.8 megagrams per hectare. I suspect this may still be a lower limit as these models consider erosion only and do not consider additional factors such as debris creation from the blast itself. We then compared this to the annual yield of 1.83 times 10 to the 7th megagrams per year, which normally occurs. And we do not see an enhancement greater than 1 until we get to about 350 meter impactor size. So that's about double enhancement. The 600 meter is nearly an order of magnitude enhancement. Given the distance of from the impact event, the number of tributaries in the San Juans, the distance to the Grand Canyon and the Glen Canyon power generation dam. We don't think that this is actually going to complicate operations for electricity or for water. However, an enhancement of 10 will have an impact on the local communities in northern New Mexico for the tributaries leading into the Grand Canyon, probably annual floods, and I do repeat annual year after year, as well as issues with water quality. And keep in mind that this model also does not take into account the toxicity, as these waters are flowing through a mining area and so could be picking up arsenic and lead and other heavy metals. Next slide, please. So in summary, a 120-meter impactor will likely have air quality and transportation effects, both ground and air corridors. Southern Colorado, the 600-meter impactor will likely extend this to 3 states, Colorado, Nebraska, Kansas, extending dust all the way up to Lincoln, Nebraska, and potentially even Omaha, where there's an Air Force base. Downstream effects do not show up significantly until we get to the larger impactor size, 350 to 600 meter impactors. Once again, the largest impact is probably going to be on the local communities, not initially impacted by the blast. Annual flooding events, water quality issues. Minimal impact is expected for Glen Canyon dam operations. I would also point out that our sediment yields are probably a conservative estimate. So thank you.
Tim, thanks very much. That's really interesting, and it's the first kind of big downstream effects discussion that we've started to have. Additional questions for Tim, please go ahead and put them in the chat window. Our next speaker is Sen Berksenel, who's a PhD candidate with the Royal Observatory of Belgium, and he's also going to talk about environmental consequences of impacts. Sen, go right ahead.
So can everyone hear me?
Yes.
Okay. So good afternoon. I am Sen Berksenel. I'm a PhD student at the Royal Observatory of Belgium. Today, I'm going to talk about our ongoing study with Orkun Temel and Özgür Karatekin about the environmental effects of small and large asteroid impacts by means of general circulation model or GCM simulations. Next slide, please. First of all, in this study, our key motivation is to simulate what kind of climatic conditions would happen if a small or large asteroid impactor hits the Earth at the present time, depending on different impact-generated aerosol injections like dust, sulfur, and soot, and different impactor sizes ranging from hundreds of meters up to tens of kilometers. To do this, we have recently developed a new GCM model, which is called the Asteroid Impact Wharf, based on the Planet Wharf model, which is widely used for modeling planetary atmospheres. So here, there is the outline of our own physical modules in Asteroid Impact Wharf, having 3 main components, namely the dynamic model, where the impact aerosols are transported, and aerosol microphysics module on the left in terms of lifting and dry or wet depositions of aerosols. And on the right, the short wave and long wave aerosol radiation module, which is coupled with the recent version of NASA Goddard radiation scheme. Next slide, please. Regarding the set of GCM, very briefly that we use 5-degree grid resolutions for our initial assessment, of course. As I mentioned, we use NASA Goddard radiative transfer scheme with our own aerosol microphysics and radiation modules. And for the ocean, we use a 1D ocean mixed layer model. Next slide, please. In this study, we carried out 2 impact scenarios based on dust and sulfur injections with 3 different impactor sizes, varying from 100 meters to 1 and 10 kilometers. The first size is similar to the hypothetical impactor of last Planetary Defense Conference in 2019, where the impactor size was nearly 60 meters. And the third size corresponds to the same size of Chicxulub impactor that hit the Earth 65 million years ago. For the central location of all these impact events, we choose the same location of PDC 2019 exercise to be New York City. Next slide, please. For the results, I will first begin with the results of impact-generated dust emissions. The first scenario is the dust release to see what would happen if a small PDC-like impactor hits New York at the moment. For this case, the diurnal evolution of surface temperatures are displayed in New York. That's the central location of impact. And in Chicago and in Washington as proxy locations, and in Brussels, where I live. As can be seen on the left up, the daytime surface temperature maxima drops nearly by 10 degrees in New York within a day after impact. However, this rapid cooling is not that long-living, where the atmosphere turns back into its pre-impact conditions within almost 20 days in New York. And because of the fact that this small impactor wouldn't emit high concentrations of dust into atmosphere, its environmental impact seems to be quite local. Even it can be felt in Chicago. There is not a significant change in local weather in Washington and in Brussels from our initial results. Next slide, please. In the second scenario, let's increase the size of impactor from 100 meters to 1 kilometer. In this case, the emitted dust after impact is enlarged from 1 teragram to 1,400 teragram. That results in a significant regional impact to climate, especially in the east coast of US, as can be seen in the right bottom panel, where a large and cold circulation zone appears one day after the impact. That indicates near freezing surface temperatures, which is unlike in the pre-impact conditions on the left bottom. Next slide, please. What is interesting is that the influence area in this 1 kilometer impactor case is not limited only around New York. Its effect can even be felt in distant locations, for instance, in Brussels, in the right bottom panel, where the daytime maxima drops nearly by 5 degrees within a day following the impact. But that quickly recover back to its initial state within nearly 20 days. Next slide, please. So now the next scenario is what if an asteroid impactor with the same size as a Chicxulub impactor that hits the Earth from New York at the moment. As you can see on the left, the surface temperatures are generally higher on land before the impact. But when this extremely huge impactor struck the Earth on the right side, the land temperatures goes really down to the freezing temperatures, even 100 days after impact or longer. That causes prolonged impact winter conditions. Next slide, please. Up to now, I have displayed what you obtain for impact-generated dust injection scenarios. For sulfur emissions, I will not go into much details because we observed similar findings as in the dust emission scenario, but with slight differences. For example, in 1 kilometer impactor size scenario, there would be 440 teragram sulfur injection based on the study of Thun. That would again cause a cold circulation zone around New York, as can be seen from the right bottom panel, which is now slightly weaker than as in the dust emission scenario. Next slide, please. So as a next step, we will refine all the simulations from 1 degree to 5 degree to 1 degree model resolutions. For aerosol microphysics and radiation, we will implement more sophisticated techniques like two-moment framework. We will also consider the effect of soot or black carbon emissions in addition to sulfur and dust emissions. And finally, we will investigate the surface radiative fluxes and precipitation rates in detail following these small or large asteroid impacts. Thank you for your attention.
Sam, thanks very much. This was really interesting, and it's really nice to be starting to think seriously about global effects. Our final speaker is also a member of NASA's ATAP team. Dr. Jessie Dotson is an astrophysicist, and she's going to discuss some of the statistical inference techniques that were used in this year's exercise to aid in characterization of asteroid properties. Jessie?
Great. Can you guys hear me okay? Great, thank you. All right, thank you, Michael. This has been a great session about all the different types of effects that can happen due to an impact. And I'm going to take a step back a little bit and talk about how do we model the properties of the impactor so that we can actually kind of figure out what range of probabilities, what range of effects we need to be worrying about. Next slide, please. So Lorian has shown versions of this slide as part of the exercise, but we have a probabilistic asteroid impact risk model. And what we basically do is we sample from the distributions of the various asteroid properties, entry properties. We have some fast running models so that we can run millions of cases and understand, infer about the damage. Go ahead, do the next slide. Here we go. And so we have this fragment cloud model that allows us to model the breakup and energy deposition. We have blast and radiation propagation models, thermal damage models, overpressure damage estimates. And this talk is going to concentrate on the initial conditions of the asteroid properties. You heard Marcia talk earlier about some of the work we're doing on tsunamis. I wanted to highlight some of the lightning talks you can check out that other members of our team are doing, focusing in on the thermal damage, the blast and radiation propagation, the overpressure damage, and what actually goes on during the flight of fragments through the atmosphere. Next slide. But in terms of the inputs, the physical properties of the asteroids that are inputs to our current fast-running deposition models are diameter, density, porosity, and strength. And you know, in an ideal world, we would know the exact parameters of an impactor, but of course, we don't live in that world. And we can get measurements, although they are never precise, of diameter. Density, porosity, and strength are very difficult to measure. We have measurements of few to no asteroids for some of these properties. Next slide. So what we've done is we have created a network where you could just sample from each of these distributions separately, but then you can end up with combinations of parameters in your virtual impactors that are not physical. So we've generated a network where we've kind of connected these parameters together in ways that physically make sense. And the goal of our inference network is to come up with distributions for each of these parameters, which are plausible and appropriate for the scenario, but also so that the combinations of these parameters for any of the impactors we consider in our model is also physically plausible, so that you're not sampling from one end of one distribution for one property and the other end for the other in a combination that would never happen. Next slide. And there's different ways you can, once you build a network and kind of establish these connections, there's different ways you can use it. I'm going to first step you through how we would use it, like on day 0, when Paul Chodas calls us up and says, okay, for day 0 of the exercise, I'm giving you an H of X plus or minus Y. What do we do? Well, we have 3 of our nodes are data-derived properties. The H is specified by the scenario. For the albedo, we use the cold neowise distribution of albedos. And for the macro porosity, we need to, we use just a population model based on a paper by Carey et al. Just Carey. Next slide. Now, 2 of the nodes, diameter and density, are deterministic given their parent nodes. So we can calculate diameter once we have an H and an albedo for a virtual impactor. And likewise, we can calculate the macro density once we have a base density and a macro porosity. Next slide. But then we have some nodes that we don't have a deterministic model of, and we don't have a good population way to generate the connection. So we infer these properties based on their parents. Next slide. And so in the end, we have a heterogeneous inference network that consists of data-driven nodes, deterministic nodes, and probabilistic nodes. Next slide. Stepping through the nodes that we infer the properties. For the taxonomy, we infer the taxonomy given the albedo. And this is a data-driven inference. It's a relatively straightforward application of Bayes' theorem, where there's quite a lovely measurements in the literature of the albedo distribution you get for a specific taxonomy. And there's also studies of how frequent different taxonomies are in the population. So that makes it pretty straightforward to infer how probable a particular taxonomy is given an albedo measurement. And you can see from this flow diagram, the lowest albedos, which are the LLs down at the bottom in the dark red, tend to flow up to the Cs. And you can kind of look through this and see that that the flow you get from the albedo to the taxonomy is probabilistic, which is great because it doesn't over-interpret the state of our knowledge, but yet it does capture the relationships that should exist. Next. Similarly, for base density, we searched the literature and we found associations in between taxonomies and the associated meteorite types. And then for the different meteorite types, you can, there are density measurements. And so for any taxonomy, we associated that with a probabilistic base density. And again, you can see that, your C-type taxonomies tend to have the lower base densities, which is what you would anticipate. Next slide. Now, to go from porosity to aerodynamic strength, we really don't have a good set of data to let us develop this inference node. So instead, we relied on good old intuition and did something a little bit hacky, but that means we always have to, every time we look at this plot, we're like, oh yeah, we don't have data behind this. This is what we inferred. And basically what we infer is that the most porous objects tend to have the lowest strength. And so what we've done is we divided the porosity up into quartiles. And so if an object with the porosity in the lowest quartile is going to end up with the strength in the highest quartile. Next slide. And so if you roll these all together, these are back to our risk model inputs, and you can see the distributions there in the diameter and in the diagonal, and you can see the kind of like the pairwise relationships in between the properties and the scatter plots. Next slide. But you can also use this inference network when you have additional characterization. And so I'm just going to give a little preview. We use this network in the planetary defense apophis observing exercise that Michael Kelly is going to talk about tomorrow. And in that scenario, We used radar measurement. By the end, we used radar measurements to provide additional constraints to the diameter, NEOWISE measurements to provide additional constraints to the albedo, and spectroscopy results to provide additional constraints to the taxonomy and the base density. Next slide. And so when you add those constraints, you can see how the different properties evolve. I've kind of adjusted the size, the number of virtual impactors in each of these populations, so you can see how the distributions change, but you can see that as you add spectroscopy, you get more, your knowledge about the diameter gets better, and as you add NEOWISE and the albedos, it gets even better, and as you get to radar, you get an even narrower distribution. So you can see the progression of our state of knowledge as we go through an exercise or as we learn more about an object. Next slide. And so then to bring this back to the impact risk models. And so this is a little bit of there's a lot going on here, but we don't have a lot of time, so I'm going to focus in on just the yellow lines. The yellow lines tell us how likely the size of what we call our serious damage radii is going to be of a given size or larger. So if you just look at the yellow lines, the different types of lines tell you what pieces of information were folded in. So the dashed line is when all we had was the H magnitude. And you can see that, we thought that, something with a damage radii of 250 kilometers or greater was 20%. And so we saw some quite large effects. When we added in the NEOWISE and spectroscopy, those gave us a very similar damage probability. The the dotted and the dashed dot lines fall almost on top of each other, but you can see the probability of the large objects causing damage went down. And then we added radar, the large objects, the large damage radii went down a little bit more, and we had a little bit more at the lower end. But I can see Mike is telling me I'm almost out of time, so I'm going to move to the last slide. And so just in summary, we have this network to simulate virtual impactors such that the distribution of their physical properties are plausible and the combination of these values for any impactor is physically plausible. We've used this network to support the PDC exercise you saw earlier this week, the Apophis campaign, and we do have some future work to improve some of the inference nodes. I think there's some ways to tune them up a little bit. And I'd like to robustify our ability to incorporate a wider variety of observational results. Thank you.
Jesse, thank you very much, and thanks to the rest of the speakers as well. The chat's been pretty busy with questions, and I just wanted to have an opportunity to talk about some of those. Looks like we have about 10 minutes before the break. Jason, there were a number of questions early on to you. So if you can unmute there. Question was if you'd been had an opportunity to look at resulting differences in the ground over pressures from the different perturbations that you applied at the surface.
Yeah, I haven't yet, and I want to say it was one of your papers actually that showed there was a certain amount of variation that it really didn't have too much of a significant impact on the overpressures. So yeah, I'd be curious to see if the kind of sense of depends on initial conditions kind of washed out in the end.
And there was a second question from Boris. Is it correct to assume that it's the Rayleigh-Taylor instability that leads to the destruction of the meteoroid in these no strength cases, I guess?
Yeah. So my understanding in the fluid limit is that it's the Rayleigh-Taylor instabilities that are the primary driver, and then you also have the KH due to the velocity shear there. But I would certainly defer to anyone else who has a little more background in hydrodynamic instabilities.
Daryl asked about the wake behind the particles, if the rarefied wake behind the particles gives you any challenges.
Yeah, it does actually. I think from a modeling standpoint, it's not really that problematic. But you can definitely see if someone goes back in their free time, if they're really curious, there are some white spots behind the solid where there is void space. Though it doesn't end up being problematic from a stability standpoint, and I think from a physical standpoint, it's not really an issue either.
Thanks very much. I wanted to go on to get to a couple of the tsunami questions. If Marcia's still around.
I'm here, and I was just actually typing an answer, but I can do it out loud now.
Yeah, go ahead.
Okay.
So the question was, what's reasonable in what reasonable computational time can we calculate the actual height of the tsunami? So I guess, and I had a question too in terms of cost as compared to shallow water or as compared to like hydrocode simulations for tsunami. So maybe you can address all of that.
Well, let me start, for example, by telling you how long the computation I showed took, which was fairly refined. All the cost is really driven by the level of refinement at the coast. We have not optimized it all, but it did take about 5 or 6 hours on a 4-core laptop. So we expect that to go up when I, for example, implement reusing the sparse factorization to go down a lot, to get a lot better when I can reuse sparse factorizations and so on like that. And also it's only a 4-core laptop, so a more powerful machine could do a lot better. So that would be 6 hours, let's call it. Desktop level parallelism. And that's a lot more expensive than shallow water. So.
And I guess, so would that give, what kind of accuracy are you confident in the height of the tsunami with that level of resolution, especially when we get onshore to inundation?
Well, the results I showed had 10-meter resolution, and the bathymetry is like 1/3 arc second. So you'd probably want even more than that and more refinement. But since once we're onshore, we're doing shallow water, not elliptic solves, that part will be, more, that won't add a tremendous amount of cost. Everybody always switches to shallow water to reduce the stencil size because it's a more appropriate model when you're in the very shallow water.
Marcia, thank you very much. I think that covers that. Jesse, there were a couple of questions that jumped in for you. Is the sample size of objects that have right. So the first question is how easy is it to update the impactor probability model, the property models, to incorporate new data? And then the second question was, is the sample size of objects large enough for the sample size of objects that have both reliable albedos and taxonomic classifications large enough to get reliable inference?
So how easy is it to update the model to incorporate new data? The answer is it depends. And to some extent, it depends on if it's a type of measurement that I've already exercised the model and I've already kind of like built the on-ramp so that I can put the new measurement into the model. I think one of the things that I love about doing these exercises, and particularly the observational exercises, is every time I go through one, there's like a slight, twist to the scenario where I learned that, I thought I had something in place that was really totally robust, and some measurement will come in that totally breaks it. And so it's getting easier as I practice. In terms of is the sample size of objects that have both reliable taxonomies and albedos large enough for inference? Ish. I think it's large enough that we can do pretty good inference. I think that there are absolute simplifications that we're making. There have been some kind of, I would say, hints that perhaps the distribution between the different taxonomic classes might vary as a function of size. There's not enough data to use that in our model. So I just assume that all sizes have the same taxonomic distributions. Given the assumptions we're making, I think it's pretty good. I think that given more data, we could do better.
How big is this? How big is the database that you're pulling from? I'm sure it depends on different classes and stuff like that, but roughly how many samples are we talking about?
Let's see. I think that I'd have to go back and look.
Okay. So I wanted to ask you a question as well. In the case of this particular exercise that Paul put together this time around, we knew so little about the asteroid on day 0. So we had a feeling for H magnitude, but no albedo. And I wanted to know, how did that dearth of information affect what you were able to do in terms of classification and asteroid properties this time around?
Well, that's kind of the starting off point for the kind of like what I call the base inference model, where I assume we know as little as possible, because I think that's kind of the strength, where when you know as little as possible, what can you infer without overinterpreting what you know about other objects? So that's kind of where we started. And so it means you have a pretty wide range of uncertainties on things like the diameter. And certainly, we saw evidence that those, that long, large diameter tail really does drive the uncertainty of the damage for a long time.
Right. Yeah, until we can eliminate that tail by further observation, it's really a challenge to pin things down too tightly. So
yeah.
There are still a couple of questions left in the chat, but we're a little bit out of time here. And so we have a break coming up. And so I want to encourage people to try to get it, if you can stick around and have a conversation, then do so, or answer in the chat if the speakers can take a look and try to respond to the questions that are remaining in the chat. Otherwise, I think we have a 15-minute break starting now before we get to the next session. Thanks very much.
Thank you, Michael. And thanks to all the presenters in the session. Very, very interesting talks. Good discussion in the chat and during the Q&A. So thanks, everybody. Enjoy the break, and we will resume here at 1:30 Eastern Time with the disaster management session. Thank you.
All right, good afternoon, everyone. Again, welcome to our disaster management session. I have 3 great presenters for us today. And again, to remind everybody, if you have a question, please address it to everyone. We'll try to make sure we get to all of them during the chat. So without further ado, I'd like each of my speakers, you have about 10 minutes each. Give a brief introduction of yourself first, and then proceed with your talk. Thank you very much. We'll start off with, I want to make sure I don't mess up your name. Jagannatha, could you start off, please? Thank you.
Chairman, this is JV for short, because my name is very long. I'm a PhD scholar at Jain University, Bangalore. My area of work is climate resilient, and I've served in ISRO as a scientist engineer, ground support for 32.5 years, and has been an alumni of International Space University in 2011. And I'm working in the area of space education outreach for many years. The summary of my presentation, next presentation, please, next slide. The summary of my presentation is community enabling planetary disaster risk reduction is sustainable. Community enabling planetary disaster risk reduction is sustainable. Monitoring and simulation of real and hypothetical asteroid impact scenarios are useful assets. Planning and design of a zero cost, real-time students and family non-formal education model for planetary disaster reduction is designed. Simple, cost-free, community-based solutions for planetary disasters risk reduction hinges on science and culture. This has been vindicated. I'll quickly run through the slides because in my 30 slides, what is important is only 2 very important slides, which speak of the design of this 10-week-long zero-cost virtual education program for 5th to 9th standard students with a handhold. Next slide, please. This is on the space vision, and also I was mentioned here, I got my full paper prepared and sent for uploading, and also my video, and I will not take much time to go through the details. I'll go to the actual heart of the paper and what exactly is proposed. Next one, please. These are all indications of what exactly is happening as on ground. For example, the heart of this presentation is that climate change, disaster risk reduction, and pandemic, these are the 3 very important experiences that the community has got today. And it is these 3 experiences. The summary is community is living through these 3 difficult situations over ages. And planetary defense should pick up clue from this. If we can enable the community to take care of its environment, we have done much of the job very easily. Next one, please. This is about how the disasters are mounting. There were 50 in 1900. They are now galloped to about 200 per year. Next one, please. And these are all realistic monitoring tools we have today. For example, EM data gives us weekly disaster monitoring. It's being surveilled, doing the surveillance. Next one, please. We have a good number of cases where the climate change has started doing irreversible damages. Next one, please. We do have a good number of population in the world living through these climate impacts. Next one, please. This is the latest disaster, and in India, for example, the disaster management has been now the pandemic management. A very old 1897 Act has been modified and has made it as a disaster management rules 2005. So there is no doubt for us to say that pandemic is a disaster. Next one, please. This is one important flyer we brought out during the COVID time. See, we did a program in the COVID time also 10 weeks to take the students and a handhold, and we could have about 60 students involved in it. And we are given every week 2-page information. And the students used to give a response, a cultural response on what they feel about the situation happening, how to live through the COVID. Here is the flyer which gives information about the importance of hand washing, the importance of climate action. Next one, please. Here, I'm sorry because it's very small, but it gives an idea how since hundreds of years from plague to the latest, the community is living through all these pandemics. Nothing new. COVID is a perfect example for technological disaster. In disasters, we have got natural and technological. To me and to many of us, pandemic is nothing but a technological disaster. The failure of public health architecture has put into all the difficulties. We have to live through it. Next one, please. We brought out a good number of flyovers. This is one Amrutaballi, a plant, a perfect medicinal plant for respiratory disorders. And these are the solutions we have today for pandemic also. Next one, please. This is the continuation of that previous slide, which gives about the properties of this medicinal plant. Next one, please. So the foundation for the model we are proposing is Triple-C declaration, which says that given individual and a community awareness, attitude, skill, knowledge, and participation opportunity, they will be able to tide over any sort of disasters, any sort of pandemics, any sort of climate impacts. Next one, please. This model we developed in 1988 is cited as one of the 20 best eco guides by the Earth Day 2000. The foundation of this model is we do not spend any money. We give information, make students to come out with responses. Next one, please. This is some sample of what exactly is happening with the space segment, where the disaster management is taken to the core. And here we need to get into the community enabling as an important aspect. Unless the community owns a space plan using the space segment, it will not be sustainable. Next one, please. This is also the 6 actions plans that are required to make the community enable. Next one, please. This again is the heart of the real-time community enabling zero cost, non-formal education we are proposing. We are having about 60 students all over the world. Some of them from US, some of them are from Australia, some of them are from Japan, and most of them are from India. They will be having every week 2-page note. It could be simple Indian space program, then the 6th Planetary Defense Conference, 7th Planetary Defense Conference, disaster management, and what exactly is happening with the United Nations systems with regard to the chemical, biological, and nuclear warfare. We are going to communicate the threats happening within planet Earth and from outside. The students will be getting the information and they will be able to manage it with the help of a handhold. It could be a brother or a sister, parents or grandparents. This is the heart of the proposal we are making and it's operational now. Next one, please. This is an example of how the students will be getting the information and what they should do. They should spend only 1 hour a week in making a painting or a poem or a slogan or a jingle. It's more creative. Next one, please. So this is actually what are all the materials we have already pooled and compiled, which contains information, so that the students are at ease to take these materials and work on it. Next one, please. So this is again an explanation. For example, the first week is on space situational awareness, space education programs, and what is exactly happening in the people science movement in India. So this 2-page information is sufficient for the students to go through in a matter of 1 week time. The assignment given is for working for only 1 hour. So these are a very simple approach, is sustainable, and we have seen it in the COVID time. The 2020 we implemented a similar program. Next one, please. Next one, please. So this again a weekly guidance syllabus. Next one, please. This is an example how a student has made a story about she converting a plastic tub into a compost place, and she is communicating this with the help of her parents. Next one, please. This is one painting by a 9th standard student on the climate change. Next one, please.
JP, we have 1 minute.
It's over, sir. Thank you. And this is a poem made on the space exploration, how a child of 6th standard, she is putting her dream in space exploration. Next one, please. Again, on climate change, a response from a student of 6th standard. Next one, please. Yeah, these are the selected references, and these are the links again repeated, which were in that model. And summarizing, I want to just say that this has happened because of a dedicated, reciprocating, voluntary support by family and my daughters and my colleagues. They are in different parts of the world. Nevertheless, the approach is very simple. With zero cost, we can do wonderful things. That is, the clue is community enabling. That is the validation. Thank you very much. I look forward for your observation and questions so that we can learn more and do it better. Thank you very much.
Thank you very much, JB. Next, we'll start with Rudy Albrecht. Rudy, please introduce yourself. I know you're well known in this community, and welcome to the disaster management session. Thank you. Thank you,
LA. And hello to everybody else, whoever they are on the planet. I'm Rudy Albrecht. My background is astrophysics. And I've been working in the Hubble Space Telescope project for about 30 years, now retired from ESA. And on the board, I'm a senior science advisor to the board of the Austrian Space Forum. With a background in astrophysics, for this particular topic, I have the collaboration of a Canadian economist, Mohammed Dor, and together we devised this talk. I want to talk about the economic consequences of the asteroid threat, and not only about the economic consequences of the actual impact, but also about the economic consequences of a mitigation campaign. This is an issue which I feel has not been addressed adequately so far. Next slide, please. So here is the mitigation scenario. Suppose we find a body of size 100 meters plus, and we determine that it will hit the Earth in about 5 to 10 years. In many ways, an ideal scenario, because this will give us enough time to design a mitigation mission. What follows is, in the best of all worlds, the chain of events which is outlined on these slides, and we have heard about this in this conference. However, and that's a big however, the current COVID experience shows that this will not necessarily pan out the way it's designed. But even if it does, next slide. Next slide, please. Yes. But even if it does, here is the impact corridor of the hypothetical object that we followed in the 2019 Planetary Defense Conference exercise. It sort of runs across the United States diagonally. The yellow circles are nuclear power stations, and these two first order indicate population density and also economic activity. So at some point, we will have to tell the people who live and who do business in this area, we will have to tell them, look, in several years from now, an asteroid will impact somewhere in this corridor. No, we don't know exactly where. And yes, we will try to deflect the object. But no, there's no guarantee that we will succeed. We will keep you informed. In the meantime, you all just carry on. Next slide. Next slide, please. Well, if we had an impact, what kind of economic damage do we expect? Our 100-meter plus object would fall into the category between 3 and 4 on this list. About 1 million fatalities, damages in the range of trillions of dollars. Well, one thing is certain, people will not just carry on. There will be an immediate effect on all economic activities in the impact corridor and beyond. Next slide. So, what do we need in order to maintain a viable economic system? We obviously need production facilities. We need to be able to communicate and to exchange goods with our customers. We need a reliable system to make and receive payments. That, of course, implies a reliable banking system. Above all, we need investor confidence. Obviously, immediately after the announcement of a high probability of an impact, all major investments will stop, pretty much everywhere in the impact corridor. Next slide, please. We also need markets which allow us to trade stocks, commodities, real estate, emission certificate, what have you. These markets will be severely disrupted. For instance, the real estate market. Real estate prices will drop drastically with all the consequences which we saw during the 2008 subprime crisis. We need a legal framework which defines and enforces the rules according to which all of the above is supposed to work. We need a credible central bank which makes sure that we can trust the currency. And all of this is being tied together by information technology and computer networks. Well, good luck. It's quite obvious that during the several years between the announcement and a possible impact or a successful mitigation, the economic activity in the impact corridor and possibly elsewhere will drastically change, especially given the fact that a partially successful mitigation will move the impact location in unpredictable ways, such as it happened during the 2019 PDC exercise, when the impact moved from Denver, Colorado to New York City. Next slide, please. Next slide, please. Okay, there are historical examples. Well, there is 9/11. The cost of that was several $100 billion upfront when the Federal Reserve tried to stabilize the currency. The total cost, if you factor in the Department of Homeland Security and the war on terror, is upward of $10 trillion. Next slide, please. Another example is the current COVID crisis. There is no, I want to point out, there is no physical destruction, but there is enormous uncertainty which just slows the economy down. The bottom line, according to this estimate, is it will cost the US about 90% of the annual gross domestic product. And we just heard a couple of days ago about the $1 trillion stimulus package, which President Biden is proposing. Next slide. Next slide. Okay, so what can we do to mitigate this, to manage this situation? On a national level, many countries have plans to mitigate the threat, like for instance, the US. On the international level, there are United Nations groups like IVAN, Same Page, COPAS, and others, which are dealing with the technical and legal aspects. We propose that these activities should be extended into a United Nations Framework Convention on the Near-Earth Object Threat. Mitigation protocols, technical and legal and economic, should be discussed among UN member countries and result into a global mitigation protocol. Next slide. Such a mitigation protocol should include action plans. A monetary action plan should define and, if necessary, declare illegal certain counterproductive and predatory economic activities. It should also introduce measures to increase liquidity and confidence in the currency. The budgetary action plan should provide guidelines for emergency legislation to maintain a working survival infrastructure and to maintain an orderly economic system. Next slide, please. And of course, there has to be a recovery plan, which outlines how to get back to a satisfactory nominal situation. Let me remind you again, this is not only required for an actual impact, but also and in particular to manage the economic consequences during the years of uncertainty when mitigation is being planned, but there's no way of knowing whether it will actually succeed. So there will be severe socioeconomic consequences even in case of a successful mitigation. Next slide. So here are our conclusions. The essential point is number 6. What we suggest is that the current activities at the level of the United Nations, and which concentrate on the technical and legal aspects, should be expanded into a UN Framework Convention on the Near-Earth Object Threat. National and regional plans should merge into this global convention. We want to point out that such a framework already exists. It is the United Nations Framework Convention on Climate Change. The Near-Earth Object Convention could use a very similar administrative structure. And with that, I'll stop and I'll thank you for your attention.
Rudy, thank you very much. That was an excellent presentation. It makes a lot of thought to that. I'm sure there'll be plenty of questions and comments at the end. Next, we'll go to Thomas on his talk on the Vipuri experience. Thank you.
Okay, hello, I'm Tamás Kohut, and together with Sani Turunen from University of Helsinki. We actually got an idea to give this talk because during the Finnish Winter War, Finland has to give up some of the territory on very short notice. So we look into historic records. How did it go, and what were the strategies to move the people and property? So next slide, please. So Finnish Winter War started at the end of November 1939 and lasted approximately 4 months. And the condition of the peace agreement, how the war was settled then, was that Finland will surrender part of the southern Karelia and other smaller areas to Soviet Union as outlined on the map with the arrows. And about 400,000 people lived in the area, in these areas to be evacuated by the time. And city of Viipuri, which is marked with the star, was the biggest city in the area, and it was quite far from the old border, so it was not a border city. It was about 100 kilometers from the border, and it was still 30 kilometers from the new border. So it was 30 kilometers inside the evacuation zone. Next slide, please. So by the time of the end of the Winter War, there were approximately 86,000 people living in the city of Viipuri, and the whole country was living in exceptional circumstances. It was a wartime. Many people, especially men, were on the front, so not all services were working well as in the peacetime. And the sudden need of the evacuation caught the city of Viipuri by surprise because it was quite far from the old border. And it was winter with freezing temperatures, and the whole evacuation needed to be done in 1 week. So there was 1 week notice to move 86,000 people. And the street was quite visible and imminent, so majority decided to follow the evacuation order. Next slide, please. So here is how the evacuation was done. It was still no internet, and telecommunications were limited, so there were issued leaflets like you see on the right side in Finnish, and it briefly translates that you have to move immediately your personal belongings next to the road where they will be later on collected, and you yourself has to travel, and the route was written in each locality based on the current conditions. So here is an example. For example, go to that train station and then take train from there to that city or so. Then it was written, be calm, calm others, and take with you proviant for 5 days. So there was not any assurance that you will get a food from somebody. Take warm clothes and blankets because it was winter. Take only necessary valuables and take only things which you can carry yourself for about 20 kilometers a day. And it was encouraged to use bicycles or skis or kickspark, as you can see on the picture, because it was a winter time. And only ill people, children or elderly were entitled for transportation, which was mainly done by horses. The healthy people had to walk at least to the nearest train station by themselves. Next slide, please. So the evacuation was voluntarily, but majority decided to leave because they did not want to stay in Soviet Russia. And there was 1 week to do the evacuation, but some people got the information with a delay. So some of them had only a couple of days or even half an hour, especially in the rural area surrounding the city. Some people were working in forest, for example, and it took a couple of days for them to get the information that they had to leave suddenly. So everybody capable of walking had to work, and transport was reserved only for belongings or these who can't work. And behind the new border, people were initially gathered in the temporary camps where was provided some basic food and animal feed, because many people took animals with them, and animals were also used for transportation. Next slide, please. So there had to be done some logistic choices. As I mentioned, most people traveled by foot, and horses were used to pull heavy belongings. They were more reliable than trucks or automobiles, and there were not that many trucks or automobiles in that area, especially in war times. Many of them were serving the army. The most valuable belonging to rural families was cattle and other animals like horses, so they tried to take them with them and steer them on the road while they were walking. And from the collection points, people were moved together with the cattle in the cattle or cargo trains, because there was not enough passenger train cars. And a lot of animals had to be left behind, mainly the smaller ones, because they were not used to walk in the snow, and it was not possible for a single family, for example, to take all of their animals with them. So there had to be done some choices also in respect of these animals. Next one, please. So what happened after that? The evacuation is considered by historians as quite calm and organized and successful. That means that almost nobody was left unintentionally behind. Only those who decided not to evacuate it stayed. So most of the people were managed to be moved. And then people were distributed all over Finland based on their places of origin or family ties or some distant family or friends. The residents of the Viipuri city ended up in Helsinki. And what is good, that despite a lot of personal belongings which were centrally collected and transported and that had to reach the people again, they were lost, the lives were saved. So this is important factor. Next slide, please. So why we talk about this? Because Viipuri is actually quite good example of a small or mid-sized city, and the distance, the evacuation distance was about 30 kilometers from the city of Viipuri to the new border. And if you compare it with Tunguska case, it's about similar. So from the center of the Tunguska damage zone to the border where the event was already quite survivable, there was not a permanent damage on the ground or not continuous damage on the ground. It's also about 30 kilometers. So it's a good example from history. If you have 1 week to evacuate 100,000 city, caught by surprise, and to move people at least 30 kilometers away into a safe distance. Next one, please. So this is a last slide. So what lessons learned are, if we need to do a rapid evacuation on a short notice, maybe the most efficient is considered light traffic, walking, biking, or skiing. A healthy person can walk maybe 20-30 kilometers a day on a road. That's enough already in the case of Tunguska to get into a safe distance in 1 day. If you bike or ski, you can go more far. With biking, you can do over 100 kilometers a day on a road. And maybe walking and biking use the road capacity much better than using car traffic, because roads can get jammed and you don't carry that many people in one car as if you use the same space by walking a crowd. Maybe trains are better also than road traffic, because there is not that much congestion on the rail lines, and if you move in one direction or you have a double-sided track, you can go back and forth with the trains with quite short sequence. The public transportation or any kind of transportation should be primarily limited to people who cannot walk. So I think that if there is an imminent danger, people just should not expect from the authorities that they will get a comfortable ride and they will get everything assured, food, water, and so on, all the way, and that everybody will be evacuated safely and on time. It's better if the healthy who can walk or bike rely on themselves. They take basic belongings, they take food or water for a couple of days, and they just go, and they free up the emergency response equipment or the evacuation equipment for these people who cannot. So it's again something similar like it was mentioned in the COVID-19 scenario. Many people do some prioritizations, many countries do some prioritizations that they ask people who can to stay and work at home, not to contact that many people, and they focus the health services for these people who are more in need, like elderly or the people who get serious symptoms and who cannot cope with the disease by themselves. So thank you very much for your attention.
Okay, thank you, Tomas. A very interesting talk from all three of our presenters. And I'll be looking in the chat room for questions. Of course, there are a lot of comments about other examples that could be not to make sure we try to cover as many as possible. But I have a couple of interesting aspects that I like to bring up. With you, Tomas, the example you gave was during the war, and some people are making comments about in a modern time. I think there are a couple of things I'd like for you to make a comment on. So perhaps there's some regional or national differences where your citizens may be more prepared. I think one of the things we're trying to introduce among our citizens here is a preparedness. Every citizen should be prepared to take care of themselves for a number of days and not expect that our rescue abilities, our forces will be there to come get them specifically, but be able to shelter in place or move if you need to. But there's also a large population that has no capabilities of moving. And so do you think that one part of the issue with a large event, in this case we have 6 months, but I'm wondering if you consider that I think there would not be a lot of citizens who are prepared to make a move like that all of a sudden, especially if they have children. If you say you got to take care of yourself for 5 to 6 days, or be able to carry something supplies with you to last for 5 or 6 days. I'm not thinking that there are a lot of people who are prepared to do that, especially in maybe more modern or built up areas. Maybe not so much in areas of the world where there's not so much critical infrastructure where people are sustaining themselves anyway. What do you think about that?
Well, if I can answer, of course, the times are changing. We are living more comfortable life. And in some countries, we are not able to do that much physical exercise or walk or so. But then again, when there is no choice, like imagine the cows, they were all the time inside or on the meadow. They did not walk long distances also, but people took them with them and they had to walk. So the choice for the cow was either it will walk or it will stay behind. That means that possibly they will kill it because they did not want that the enemy will get it. So I know that it's unfortunate, but when there is a danger, people possibly need to try to do as much as they can. So we can focus the rescue efforts for these who really can't.
Okay, thank you. I think as an emergency manager, I think that a lot of times, and I've spoken with this with my other colleagues when we've done tabletops here, evacuation is a much more complicated exercise than people think. So I would like for us to just keep in mind that it could be extremely complicated. You have different kinds of populations, you have different capabilities. Everybody getting in their car is probably not a good thing. Rudy, I thought your presentation was really fascinating about a convention to think about this in a holistic way. During our last tabletop with FEMA and NASA, the economic part was discussed, but there was no real clear way of thinking about how do you take care of this, especially if we have a multiple year warning time. So I'd like for you to kind of explain how do you think you would initiate or something like that should be initiated?
Well, it's a difficult issue. The reason I got into it was that I tried to estimate the kind of damage, the kind of economic consequences of an impact. And then it occurred to me that even before the impact, you introduce a lot of uncertainty into the economy if you tell people that in several years from now, something drastic is going to happen. Because who is going to buy a house? Who is, well, everybody's going to try to sell their houses to get out of the impact corridor. And we saw what happened when the housing market broke down in 2008. It had serious consequences for the economy. And I'm just concerned that this is going to happen again. And we need to put into place mechanisms to catch that in time, or strategies to convey the situation to not the people, but to the system in such a way that we avoid this economic disaster, because that's what it's going to be.
So, Rudy, do you think that, considering that we've been discussing in the PDC communications, the idea that if our science colleagues shall discover an object and we have years warning and we are going to mount a deflection or mitigation campaign, but it might be unsuccessful. the word is going to get out that such an object has been detected. So
yes,
I don't know. I'm not sure how we would. Some of that's going to happen anyway because it's not going to be a secret route. It's going to get out pretty fast, I would think.
absolutely. And it would be ridiculous if we successfully deflected the object and still had the economic damage. So there might be a question: up to which size do we just which object size do we just let things happen? You know, in the 2019 exercise, the object was headed for Denver, Colorado. So if we let it happen and we rebuild Denver after the impact without the economic uncertainty ahead of the impact, we just rebuild the city. Of course, people who live there have a real problem. But instead, what we did was we identified a possible impact corridor, which went right across the United States, you know, across the area where most of the automobile industry is concentrated. Across, as it turned out, we lost New York City at that occasion in that tabletop exercise, and that actually was what triggered my thought process about the economy. So instead of just rebuilding one city, we introduced a lot of uncertainty, economic uncertainty for years for a whole country. And well, even if we succeed in deflecting the object, we still have the economic damage as if it had impacted.
Okay, I think this is going to be a very challenging issue if we find ourselves with a long range issue. I think that our citizens are going to assume that people who are brilliant and like in this group will come up with a plan that will take care of this. But as you said, it's going to take an international effort. And switching gears for a second, JV, you talked about is your ideas that the way that we can get planetary defense more acceptable, so to speak, in the international community is an education program. But does that aim only toward a certain age group? Because it seems everybody will be affected. So I want to understand how you think your approach would aid overall, since it's going to affect more than just a school age group of children, and we might not have a lot of time to do it. So what do you think? Maybe especially since you talked about the Tbilisi guidelines, I just want to know, how do you think that's going to affect, and would your program only affect a certain age group? How would that affect, how would that go over for the rest of the population? I can't hear you.
Hello?
Yes, I can hear you now. Go ahead.
No, I had a reflection on these economical issues. 2019, when you were in 6th PDC, $5 billion US dollars were allocated by NASA for restoration plan. I think it should be on by now, the planning activities. What I want to say, after the disasters, for example, after COVID, US government has allocated $80 billion. I think the issue has to be preventive in nature, not curative. The COVID is teaching us the curative is not going to help any longer. So in the planetary defense also, we have to go for a preventive strategy so that we minimize the disasters. Unless we have that strategy, we'll be incurring a lot of financial and life loss and most importantly, ecological losses. An impairment in the ecological level is never quantified. I think it's a very comprehensive approach that is required today. With the best of modeling and simulation of even the ecosystems, I think we can quantify the damages that could occur and come with some, because we have a parallel economy. We have all the money in a different place, not in the planetary defense and planetary protection. I think it's also very important.
Okay, I see a couple of comments here from Clark Chapman and Brent with regard to evacuating, the difference between evacuating for a couple of days, with a couple of days warning. We've discussed this in our exercises and our tabletops. There's going to be a different execution checklist for the time period we're given. So again, your particular talk, especially Rudy, it kind of aims back to what I did not expect to think about, that the technical methods of finding the objects extremely early and getting the best data possible with regard to where the impact point is going to be extremely important, because we're also going to have to, I think, have the disbelief factor. You know, even when we do evacuations for short events like hurricanes, whatever, we always have that group of people who refuse to move because they don't believe us. They think the satellite picture's faked or whatever it is. So it kind of aims back to that. I'm not quite sure if anybody has any suggestions, or if this is probably goes to our communications experts. I think if you give over a year or so warning, there's going to be a certain group of people who are going to pay close attention, but everybody else is going to ignore it until the last second.
Well, I'm not so sure. You know, in our current exercise, we have an impact area, or a possible impact area, which covers 3 countries. And there was a presentation from somebody from Airbus. And of course, the Airbus facilities are all over Germany, and so well within the possible impact area. So I asked the question, because he was proposing to hijack an existing commercial satellite and use it as a mitigation mission. And I asked the question how certain he was to have the workforce available. And he said, well, the engineers, they would want to stay because they want to do something for the planet. Well, that's all nice and dandy for the engineers, but how about their families? How about their kids? How about the teachers, the doctors, the law enforcement personnel? How about the drivers of the trucks who bring in the parts that they need for the mitigation payload, and who take the mitigation payload to the launch site? The whole system will break down, even if the engineers will stay. And in addition, for the 2019 exercise, keep in mind that we kept moving the impact area from Denver in bits and pieces in steps all the way to New York City in Central Park.
No, what I want to add on is modeling and simulations as science is always welcome. It is not that we do everything, deflection and nuclear, ways of disintegrating the external threat. It's not that. Science is science. The application of science has to be social. So we have to learn from these simulations. For example, the first PDC was just on algebra and geometry and the simulations. Today we have a very clear-cut recovery of materials from the near-Earth objects. You see, I think we have to appreciate the science and appreciate the different simulation so that the scenarios are available. But I am of the opinion, unless the community is enabled, community has got the best of the information, we may not be able to make the ends even. It's very important.
Tomas, do you have any comments that you'd like to make with regard to the overall situation? This is something that I know is probably not as technically challenging as what we usually talk about here at the PDC, but these are all very important issues that'll have an effect globally, despite whatever technical measures we make. We'll still have to think about this. And my whole thing as a disaster person is thinking of what we can do in the immediacy. But if you give me years, if we have years of warning, there are a lot of things that go way past the disaster management authorities. This is it goes more toward what Rudy thinks. It's more of a United Nations. It's nation states getting involved with each other and figuring out what the answer is. In this particular scenario, you know, for here in the United States, I have 50 states, but in Europe you have different nations and trying to coordinate. And also the fact, I don't know if you covered this, Rudy, but you know, if you determine where the impact is, the consideration that the damage there might be permanent. Who says you're going to rebuild it or let people move back?
True.
I have audio problems. I don't hear all of what you're saying.
Okay, sorry. Sorry, I was just wondering, we're considering that there might be large damage, and you talked about once about whether we rebuild or not. There also another consideration is that there may not be anything to rebuild. Our decision might be made to leave it as it is and relocate everyone. And I can imagine the difficulties where you have different citizens of different nations that have to be moved out permanently. You may not always have the space or displace everybody internally.
Absolutely. I'm not at all certain that the citizens of Spain will be all that enthusiastic to accommodate 10 million refugees from Austria, Germany, and the Czech Republic, who are never going to leave because there was an impact. So their homes have been destroyed.
Yes. So we have six minutes left, and this is an extremely difficult issue. Rudy, I think you've touched on what might be actually the major issue with regard to a planetary defense scenario, especially if we assume that if we're always lucky in the movies, things always work out, but there's a possibility that things won't work out with a technical mission. And I think this is going to require more discussions and probably specialized discussions that just talk about this aspect of what a planetary impact might entail.
Yeah, true. Many interrelatedness and interdependent things are there. It's very complex. There is an unequal economy. See, when you go and tell people about planetary defense, the first question we get is inequality challenges well-being. How are you going to nullify the inequality? See, such things we have to address to people, no? Both at local level and the global level. Not only planetary defense questions and solutions matter. Thank you very much.
Anybody want to make any closing comments or give us the solution to this extremely difficult issue in our next 4 minutes? If not, Brent, I'll turn it back over to you. And
if I can add to this Denver exercise, which was on the last conference, and this exercise which we have now. Yeah, so maybe any relocation or evacuation goes better when is it within one country. So I think if it would happen within United States, and of course, if you have 10 years, it's feasible to relocate Denver area and rebuild. And you can also, for example, compensate people for the lost value of their property or lost property, because many governments are spending huge sums to compensate industry, for example, if they close a mine due to environmental issues or so, they compensate them for the lost profit or so. But yes, if it would happen in Europe, where we are scattered into many small countries, so there are maybe more national tensions. So if we would have to evacuate people from one country into another, especially on a short notice, that would maybe do more tensions. That's why also this kind of evacuations due to natural disasters are maybe more successful and people are not suffering that much than what is happening in wartime, when there is always some hate between the parties which fight against each other and they try to turn their hate into the civil citizens and so on. So yes, the national borders, even so when we have no chance, it has to be taken into account that there can be potential for some conflict or tensions if we have to cross the borders. But then again, with the Denver, due to the not that successful mitigation, it was moved from Denver all across up to the New York City. Imagine that if it would happen in Europe and you would not mitigate well and you would shift it from Czech Republic to Spain or so, then you will create actually a big trouble. So one has also, and it was addressed during the exercises, one has to think if a bad mitigation is better than no mitigation at all, especially when it influences then more countries and you shift it from one country to another.
Yeah, it's kind of a catch-22 situation.
It is indeed. Okay, Brent, we have 1 minute left. I'll turn it over to you.
Thanks, LA. And thanks to all the presenters for excellent presentations and a great discussion.
Thank you. Thank you very much. Thank you.
Yep. So as we close today, the thought that I'll leave everybody with is that planetary defense is a unique natural disaster in a number of ways, not just because it's foreseeable and preventable, but also because it presents opportunities for cooperation in very thoughtful ways. Yeah. So one of the things that I take away from this session is that the solutions are not obvious yet, at least not in many ways. But I think we have a good list of things to work on and hopefully have some new ideas to share at the next PDC.
Yeah, one people, one earth should be the philosophy that can make a big difference.
Let me just say too, Brent, this is really really makes it very evident that finding these things before they become a threat and trying to do something about them is incredibly important. Ideally, we can deflect these things, but we've really got to get to the point where we have some confidence that we know where they all are, and we have the ability to move one if we find a threat. So, I mean, I think this was an excellent discussion, and I think that was just a great panel. So, thank you very much for LA for leading it and for all the participants.